moderator of the session, Professor Sanal, my dear faculty members, and dearest students. So today we are here to discuss upon a very important topic. As we know that after the green revolution and white revolution, now it's blue revolution, that is drone revolution. So the UAV companies are expanding day by day, and there is a plethora of opportunities that is available for aerospace engineers, not only as the form of jobs, but also as the form of your entrepreneurship ventures. So what are those opportunities? What are the challenges? What are the opportunities? What is the current scenario? Today we have a bunch of great, vast, experienced panelists, which you will be just introduced with me, and we'll hear their insights, and I'm sure there will be a lot of takeaways for us. So for beginning, I would like to call our most respected director, sir, and session in charge, Professor Dr. Sanjay Singh, to welcome the panelists. Sir, please.
Dear students, today I am very happy because leaders are sitting here. So, industry leaders. So, give a big round of applause for the industry leaders. And we so we have with us Mr. Ashish Acharya at CA Simulation Private Limited, Mr. Ashish Kumar, CEO, Atavri Aerospace and Defense Private Limited, CEO, Aditi Technologies Private Limited. Next is Mr. Vivek Pandey, Head Business Development, Applied Electromagnetics Private Limited, and Mr. Jen Sinha, Program Manager, Alcomponics, Aerobi Technologies, and online we have Mr. Vaishnav, CEO and founder Aviotron Aerospace. My faculty member and students, a very good afternoon to all of you. On behalf of our Honorable Founder President Sir, Dr. S.O.K. Chauhan, Honorable Chancellor Sir, Dr. Atul Chauhan, and respected Vice Chancellor Madam, Dr. Balvinder Shukla, I welcome, and on behalf of my student, faculty member, I welcome you, sir, all industry leaders to the Amity University, Uttar Pradesh. Amity University is organizing 5th International Conference on Entrepreneurship, Innovation and Leadership from 14th September to 16th September under the able leadership of our respected Vice Chancellor, Dr. Ravinder Shukla. The theme of this conference is Next Generation Tools and Strategies for Business Growth and Industry 5.0. So during the conference, 3-day conference, many panel discussion sessions, various competitions, business plan competitions, design competitions will be conducted, and more than 200 research papers will be presented in different tracks of this conference, very important conference, and more than 300 speakers from national and international universities, institutions will address the students in different tracks. So as a part of this conference, AIE is organizing a panel discussion session on the development and prospects of drone industry in India for startup growth. So the objective of this panel discussion is to spread awareness among the students about various opportunities in the drone sector so that you can join drone industry as control engineer, design engineer, AI engineer, or you can also start your own venture. So we have industry leaders with us. So in this session, in this panel discussion, you will learn from the industry leaders that what type of subject knowledge, what type of competencies, what type of skills will be required to start a drone company or to enter in the drone industry. I am sure that you will note down all the deliberations, important points during this panel discussion session, and will prepare a proper action plan to achieve your goals or to start your own venture, or if you are interested in joining the industry. So once again, I welcome all the industry leaders, and I must thank all industry leaders because every time, every year, they offer this internship opportunities, placement to our students. Okay, if we are not able to arrange the internship due to various reasons, so I call Ashwani ji or Jan ji or other Mr. AKB and other dignitaries here. So can you provide internship to our students? So they are very supportive. They say, okay, bhej do, koi baat nahi, bhej do aap. You send them. Okay. So give a big round of applause for all the industry leaders. Thank you.
We are delighted to introduce our esteemed panel of experts who bring a wealth of knowledge and diverse perspectives to today's discussions. Mr. Ashwani Acharya, who will be chairing this session. Before that, I now request Professor Sanil Sir, the moderator of today's session, to felicitate our respected director, Amity Institute of Aerospace Engineering, and in charge of session, Professor Sanjay Singh Sir, with a memento. We are delighted to introduce our esteemed panel of experts who bring a wealth of knowledge and diverse perspectives to today's discussion. Mr. Ashwani Acharya, who will be chairing this session, is the head of JVBU and CAE Simulation Training Private Limited. Mr. Ashwani is presently heading the joint venture of CAE and Interglobe in India. CAE Simulation Training Private Limited is a world-class pilot training center that strives to establish and manage a comprehensive, high-quality solution for aviation training. It boasts the largest facility for Airbus A320 pilot training in India, adhering to the highest standards in the industry. He is a professional leadership coach specializing in mentoring and developing leaders, providing guidance to entrepreneurs and startups, and assisting organizational leadership in enhancing operational efficiency for increased profitability. He also serves as an ambassador for reshaping organizational culture. With extensive experience working with both international and domestic organizations and airlines, he excels in establishing and building organizations from the ground up. We are very grateful to have you, sir, as the session chair. We are privileged to have with us Mr. Vaishnav, CBO and founder of Aviatron Aerospace, who has joined us online. Mr. Vaishnav is an educator who is revolutionizing today's education and workforce to the power of STEM, STEAM, and experiential learning. As the founder of Aviatron Aerospace, he has played a pivotal role in shaping the company's path towards growth and profitability, while positively impacting the lives of thousands of students. Mr. Vaishnav has been participant in various national and international platforms, events, and competitions, including Shark Tank India, Horses Table, and AIM Dubai.
He's also received various accolades and prizes and was named Private Business Honor Board of Sonic School Chittagong. In terms of his education, he has a Bachelor's of Engineering honors in aerospace from the Faculty of Architecture, UK, where he achieved first class honors. It's an honor to have you, sir.
The honor is mine. Thank you.
We are honored to have with us Mr. Vivek Kumar Pandey, Head Business Development, Applied Electromagnetics and co-founder of Gallus Technologies Private Limited. Mr. Vivek Kumar Pandey is a highly skilled and experienced business development professional specializing in Indian domestic defense, export and offset business. With over 16 years of expertise in the field, Vivek has an impressive track record in Indian domestic defense and aerospace business development, offset, and international business development. He has successfully handled clients ranging from defense PSUs, DRDO labs, and Indian Armed Forces for domestic business to leading international defense and aerospace contractors and government bodies from diverse geographies for export business and technology tie-ups. Vivek's achievements include managing complex and sophisticated technology transfer projects for UAV from DRDO, demonstrating his proficiency in navigating challenging scenarios. With his extensive knowledge and accomplishments, Mr. Vivek Kumar Pandey is a valuable speaker with insights into the intricacies of the defense and aerospace industry.
We're excited to have with us again Mr. Jayan Sinha, Program Manager R&D at Elconphonics Aero Technology. Mr. Jayan Sinha is a highly accomplished Program Manager and Unit Head at Elconphonics Aero, responsible for overseeing the DCPP program in collaboration with PBR and DRDO and leading the UAV development program for Army Air Defense. With extensive experience in conducting high-altitude testing at Ladakh, at approximately 4,600 meters, he has demonstrated expertise in the field. He's also published around 25 research papers, and his contribution to research was recognized with a Young Researcher Award in 2021. His expertise also exposed to delivering lectures at prestigious events like BOSTA 2020 and serving the FEH for Quality Council of India. His impressive achievements and knowledge make him a valuable asset as a speaker in most technical and defense-related domains. It's an honor to have with us Mr. Ashish K, popularly known as AKB. Mr. AKB Ashish is the CEO and founder of multiple aerospace organizations. As the CEO of R3 Aerospace and Defense Private Limited, Aditi Technologies Private Limited, and Bios Estate Private Limited, he is an accomplished avionics engineer, combines hands-on expertise and an unwavering commitment to excellence in the aerospace industry. His illustrious career has seen significant contributions spanning aircraft manufacturing, aviation regulations, and jet propulsion. Commencing his journey with a focus on aircraft manufacturing, Mr. Ashish made notable strides in roles encompassing fuselage integration, quality assurance, and pre-delivery flight tests, notably with the renowned Pilatus PC-12 in Switzerland. His leadership exemplifies dedication to the highest aviation standards. His comprehensive understanding and certification of DGCA civil aviation regulations cover commercial airworthiness and unmanned aerial vehicle UAV operations, underscoring his commitment to safety and regulatory adherence. In 2018, Mr. Ashish founded R3 Aerospace and Defense Private Limited, pioneering cutting-edge artificial intelligence development for military flight simulation programs. This initiative signifies dedication to revolutionizing military training and fostering innovation across sectors. Beyond entrepreneurship, Mr. Ashish serves as a business strategy consultant and executive consultant, providing strategic insights to startups in the aerospace and real estate industries, emphasizing his commitment to growth and innovation. Participating in the panel discussion, Mr. AKB's diverse experiences ranging from aviation engineering to entrepreneurship promise to inspire aspiring aerospace professionals, showcasing the limitless possibilities within the industry. We're grateful to have you, sir.
Now I would like to request Professor Sanal to start to break the ice and introduce with the session, and so that we can continue with the panel discussion.
Good afternoon, ladies and gentlemen, distinguished guests, students, friends, and industry leaders. I'm honored to welcome you today discussion on the theme Next Gen Thoughts and Strategies for Business Growth in Industry 5.0. In this rapidly evolving landscape of technology and industry, we find ourselves on the brink of a new era, Industry 5.0, which promises to transform the way we do business. Today, we gather to explore a topic of immense significance and promise, the evolution and prospects of drone industry in India, specifically in the context of fostering startup growth. To set the stage, let us first understand what Industry 5.0 represents. We have come a long way from the first industrial revolution followed by steam engines to the fourth industrial revolution driven by automation, data, and Internet of Things. Industry 5.0, however, takes us even further, bridging the gap between human machine and emphasizing the collaboration and human machine interaction. As we venture into this new era, we are faced with unique challenges and exciting opportunities. The convergence of technologies such as artificial intelligence, blockchain, 5G, and augmented realities reshaping the industries across the board. But how can we business harness these tools and strategies effectively to drive growth? The key factors we found are next-gen tools, innovative strategies, human-centric approach, success stories, and case studies that we are going to hear now to drive the growth. Next tool and generation for business growth in industry is about embracing the future with innovation, collaboration, and human-centric approach. I'm sure that our panelists will share their insight into creating resilient and forward-looking business strategy. Thank you for being part of this journey, and let us now embark on this exploration of the future business. Looking ahead, the prospects for startup growth in the Indian drone industry are exceptionally promising. As the nation embraces Industry 5.0, the Industry 4.0 principles, drones are poised to play a pivotal role in automation, data collection, and decision-making process. Furthermore, India's ambitious infrastructure projects, disaster management requirement, and evolving healthcare needs present a vast canvas for drone innovation. In today's discussion, we will delve deeper into the landscape. Our expert and industry leaders will share insight, success stories, and the challenges that lie ahead. We will explore the role of technology, regulatory framework, funding opportunities, and collaboration in propelling Indian drone startup to new heights. Thank you for joining us in this exploration possibilities. With this brief remarks, I please to invite Mr. Ashwini Acharya, who holds the position of head of JVBU and serve as the head of CA Simulations Training Private Limited, for chairing this section entitled The Evolution and Prospects of Drone Industry in India for Startup Growth. Over to Mr. Ashwini Acharya.
So first of all, thank you, Dr. Sanjay, a brilliant event organized by the MIT University, appreciation for the management and the leadership at the university. I think this is one of those things which will take us where you all want to be, to a path of success and glory, right? We all agree? Okay. So please do respond. You'll respond, yes or no? Yes or no? How many of you have planted a tree or a sapling or put a seed in the soil? Brilliant. So all of you all. So when I was coming and preparing for this session for today, of course, I knew there is an esteemed panel who will cover the details and the nitty-gritties of the operating environment which we are going to talk about, which is drone industry. And there's so many facts and figures, and this 1 hour is far lesser time to even touch on top lines of those. So what I will touch on today is Now that you've all planted a sapling or a tree or put a seed in the soil, this opportunity is in the form of the seed of the opportunity, of the potential of the industry, and also to harness your own potential. And you can only do that once you at least understand the importance of how a seed grows into a fruit bearing tree, right? So, how a seed would grow into a tree, what all it needs? Very quickly. Water, what else? Sunlight, very good. What else? Fertile soil, what else? Sorry? Passion, wonderful. What else? Sorry? Air. So there are many elements which will make the seed to grow, which are many elements which will make it bear fruits at some point of time, right? So this session, take it as a seed of thought into your minds that drone industry is the next big thing which is happening not only in India but globally. I'll give you a very small number. I come from training environment. Of course, I'm an engineer like most of you are going to be. I've also done some management courses. I've done some international management courses. I do all kind of things. But I've learned that if you have the seed and if you nurture it well, it'll grow and bear fruit. Now, drone industry is still in the very nascent stages as far as potential of commercialization is going to be talked about. When training, I was just looking, what is the number of pilots needed to have this ecosystem of, so the government of India in one of the projections has said that we will need about 100,000 pilots to operate these drones which are coming in future, right? That itself on a very rough estimate of salary packages makes it about 6,000 crore ecosystem. We're not even talking of manufacturing, we're not talking of servicing, we're not talking of training, we're just talking the pure number of people who will operate this drone industry, the pilots who will be trained, and then they will operate this drone industry. So the potential of this seed is so brilliant. And if some of you just put a little bit more elements how to nurture that seed, I think we all would have made a success of the gathering today. Now, few thoughts on the fact that India is looking at this industry in such a big way that the projection is that by 2030, India would be the global head or the global hub in the drone industry across the globe. It is talking of $1 billion industry in this segment. Now, in a commercial aviation, if you see, we have about 700 to 800 commercial planes, and we have about 7,000 pilots, right? Now here we are talking of a number which is cannot even be forecasted right now as to how many number of drones would be required. Now these drones manufacturing, these drones designing, the R&D, the payload use. Can anybody know what all drones are used? Very quickly, raise your hand and tell me. Drones are used for what? Surveillance, rescue operation, agriculture, payload delivery, cinematography, very good. You want to go to Mumbai? Defense. So you see almost every segment of the ecosystem you look around would potential have a use of drone. Now, do we have so many drones? No. Do we have the capability as of today to manufacture those drones quickly? No. Do we have the commercial viability for operating these segments? We're still very early stages. This means what? This means that all of you all have a brilliant opportunity to look at this drone industry and then figure out how you want to nurture this seed in yourself, right? I'll not take much time because we have an esteemed panel, but the last two bits from my side is that the growth driver of an industry is what is the forecast looking ahead 10 years, 15 years, 20 years, right? So the growth forecast for this industry, you have already seen probably 10 years behind the sci-fi movies where you have the airports, the unmanned aerial vehicles flying all over the place. That day is not far away when we have those above in our skies. Yeah. So the sky is the limit. Now the sky is also not the limit. So make best use of your time here today, and also whatever time you have left here, and what some of you I spoke to, you want to do higher studies. Make sure that you take the best advantage of a brilliant institute you are in, the brilliant platform you have been given, the availability of the, I just 300 speakers are in these 3 days going to be addressing students in the campus. I think that itself is that environment of nurturing the seed. I mean, you are the seed now, right? We are only trying to help you to grow and bear fruits. So that at some point of time, one of you will say, "Sir, I had met you at that time. Take a free ride in my airport taxi." That will be the most happy day. On all that, thank you so much. Wish you all the very best. And I'm sure let's hear from our experts what holds for us in future. Thank you. I think the session is open, so I would request Professor Samal to throw some questions to the panel, and let's see. Thank you.
Only my one basic question, because audience are most of the students are here. What skills and knowledge should aerospace engineering students practice to meet the demand of the evolving aerospace industries in India? That's my specific question now. Student skills.
Thank you. Thank you for this question. So basically, my experience, I would just like to brief you why I'm talking, going to the direction where I am. So I started my career as a R&D engineer in L&T. So I have designed Pinaka rocket launch. Hello. Yeah. So basically, I started my career as a designer of your rocket launchers, electronic warfare system, basically jammers, and then went into the complex technology transfer from a DRDO lab called AD, Aeronautical Development Establishment. Recently, since last 2 to 3 years, I have been involved with the startups. So what I see, suppose either we are catering to the civil market or to the military market. So civil market requires a different type of a skill. Military market requires a different type of a skill. So now I previous to this company or my venture, I was heading a company called Elcompanics Aero, where I got an order from a TBRL, from a DRDO lab called Terminal Ballistic Research Laboratory, where we got an order for loitering aerial system. So they wanted it to be qualified for MIL 810G, your JS Penta 5 qualification. These are military standards qualifications, and your product should qualify for MIL 461E and all. So the bunch of your freshers who were with me, including Mr. Jayan. So we had no idea. Suppose you can't qualify your drone suddenly. You can't make a drone and say that it will pass the vibration test. It will pass your radiation test. It will be not susceptible to the enemy radar signals, so jamming and all. So it was basically that concept starts from the very beginning. So what we lack today is very big. So what the skills are required, that you should know in which industry you're working. Suppose you should know the standards well. You should know that what is MIL 810G. So what type of vibrations your equipment will be subjected to, what type of equipment or your bomb components you should select so that it will withstand. It doesn't happen after you make a product and go for qualification. So you should know all this qualification. You should know which market we're addressing, either civil or your military. Military requires a different type of a skill. You should gather those type of a skill. You should read about the standard. You should, while component selection also, you should, all your material selection or any selection, you should have always a feel that my equipment will be you're operating in a very challenging environment. So whether my whatever I have selected will pass or not. So this is the basic which I feel. Rest everybody knows avionics. Good people are good in autopilot. People are good in you can go mission planner. People are good in selecting picksock and all. But when you integrate and go, and you can ask Jan is facing this tender. Actually, the TVRL project I only brought, and then these people are executing it. So they know now what the challenges they face. So basically, these are the things which you should take in mind we should keep in mind too. And then definitely studies are different, but basics should be correct. You should study, you should know the standards, you should know the different terminologies and all. Just a minute. Yeah.
Yeah, just add a few point. It's okay. Yeah. So I would like to ask a few questions. Like, how many of you are in third year or second year? So okay. So most of us like from first year or second year, maybe, right? Second year and third year. Okay. So basically, I think you have already gone through the aerospace domain and what is not, what is that, right? So I will tell you out of my experience, when I walked into a manufacturing shop floor, I saw more than 50,000 of components are getting together and building one single aircraft system. So basically, when we talk about a drone or aerospace product, it is a system of systems. So if you are studying a book and it has multiple chapters, means like have a note of this, you can note it down. Every single chapter is a career path. If you just go for guidance, navigation, control, if you go for mission planning, if you go for autopilot, speaking of autopilot, there are, I think you must be knowing, there are 5 levels of it. Level 0 to level 5, subsidiary automation to full automation. There are multiple threads to that as well. Coming to propulsion and many other fragmented parts of the aerospace industry, each having its own career path. When we talk about drones, UAV perspective, what we should pursue to get into the industry, maybe as an industry leader, maybe as a working professional, which we call experts. You can be an expert in every single field if you choose any of those. Let's say I'm choosing the propulsion. In the propulsion also, there are multiple things: the sensors, the engine, the thermodynamics, the thermochemistry. You can be a chemical engineer and still get into aerospace, still get into drone industry, where military drones are having jet engines, scramjet engines, ramjet engines. Apart from that, there are FedEx system, which is now getting connected with autopilot and auto landing systems also. So all these things are getting together to build one single system, which we're talking right now. But you can actually diversify your thoughts, select one single thing, be an expert, go for the industry. That's it.
Thank you Ekam, for your wonderful thoughts. And now let's know the thoughts of Kumar Pandey. Few thoughts. Could you please share that? After that, I will invite Vaishnav. I can. Okay, you want to further insight? No.
Further,
Okay,
I just want to add that you should know the standards. Basically, you are making a product for an end user. So if my end user has been always a military, so you should know what the end user wants. And whether you are, so there is a difference between academicians and your actual system integrator or deliverer. So you should have that, you should know what actually your end user wants, what type of situations he will be handling. Like you should, so the drone what we are catering to right now should operate from -30 to +70. So you should know you can't select any component and they will work in that. So you should know your subject well, you should know the products well, you should know your customer well, you should read the complete requirement and the standards. I have given you few of the standards which you can note it down: JS Penta 5, MIL 810G, MIL 461E, and those you should focus, and accordingly you can select, because your equipment will be subjected to that test as a component, as your whole system.
Thank you, sir. Now I'm pleased to invite Vikram for sharing his thoughts. Over to Vaishnav.
Yeah, I thought that was my cue, right? If I'm not wrong. Am I audible clearly?
Yeah. Yes. Yes.
Okay.
Yes.
Okay. Perfect. So first of all, a huge applaud and thanks to the Department of ICEIL for arranging such a great session. Unfortunately, I was not able to travel back to Noida physically for the event. So I'm joining from a Starbucks in Bangalore, the technology, right? What we're talking about today. So, and if we talk about coming to the topic about, skills, so the panel has already covered a lot of technical skills that we talk about. But looking at my standpoint, if I take you guys even 2-3 years back, when you didn't even decide that you were going to, take aerospace engineering or actually decide that what particular stream you will be going to. I would say any domain that you wish to pursue, the skills always lie in three particular sectors: your technical, interpersonal, and the most important, exposure. Because we can talk a lot about different topics or different subjects or chapters that you can go through, and I'm very sure the university is already doing all of that for you. But because the segment is so nascent and it is so innovative in its own terms, a lot of factors or a lot of skills that you have to develop will have to be very innovative and critical in its nature. So you will have to decide on your own at a very early stage that maybe I should have a little bit of exposure. If you do an internship with someone, those will be very different skills that will give you a very great idea of what the industry is actually doing. Again, beginning with whether they're in manufacturing or education or training or just providing service, or or actually building a real satellite that is going to be launched and they require some similar technology that is also used in drones. Good thing with drones is it is an interdisciplinary sector. You don't even have to be an aerospace engineer purely to get into the drone sector. I have a lot of people, the first people in India who actually got the pilot licenses and were actually building their own drones were not even aerospace engineers, to be very honest, right? So they were just hobbyists, who were part of Aero Modeler Association of India. They were doing it for a long time. And when they saw that now drone is booming, they actually got into that. I even have a grade 11 student who earns anywhere between 40 to 50K right now, just doing surveys for a construction company, grade 11. And he's got a drone pilot license from the government of India. So that is the scope I'm talking about. So we're not even talking about a lot of technologies and skills, but the intent and the mindset that you actually want to develop if you want to get into this sector. Just as an example, the scenario of the whole college training placement just 6 years back in terms of drone was only some random company coming to the university, telling people how to assemble, how to screw, and actually going to the ground and sir, उड़ा के दिखा दो कैसा लगता है. This is what drone was all about, even 5-6 years back. Even in IITs, I'm not even talking about any other college. But the extent and the pace with which we have grown now, so it has to be your own mindset, your exact pathway that you've decided that if I want to get this, then you decide what technical skills, what interpersonal skills, and what kind of exposure you need to have. And then I'll definitely add more in the coming questions. Thank you.
Thank you, sir. I do have one specific question now. So what is the role of research and development in driving innovation in the drone industry? And how can startup collaborate with academic institutions and research centers to stay on the cutting edge? Hope you can share some of your views.
That is for me, right?
Yeah.
Okay, right. So a very interesting topic for me when I talk about industry and academia collaborations, because the whole idea of me even starting this company kind of came from academic collaboration. So back in 2012, when I was in UK doing my bachelor's in honors in aerospace, so I'm like all of you, I'm an aerospace engineer as well. The whole inspiration of opening something for my own came because in my university, the automobile lab was set by Ford. Right, so no relation to drones and everything, right? But the kind of inspiration when I saw, because the internship exposure, the live projects that I could work with, and the kind of research intent that the company could get without spending too much was too easy when you work with a university. So there are two different aspects of this. Either a bigger MNC or something like Tata and Mahindra collaborating with someone. Then for them, it will be just usage of funds and something futuristic that they want to do, and they'll rather dump money on the university to do it for them. Another aspect is for a younger startup who will talk about a very specific segment of research segment that they would like to work with the university. So this can be done in a various different aspects. For me, when we started working with few of the universities, number one was giving out live projects to the existing PhD and master's students. So that can be very easy or very simple segment. No funding required, no money required. The company will put in a little bit of funds, whatever is required for the project to be finished, and even the university doesn't have to pitch it in. Then we go to a one stage higher when they're actually establishing labs, and the company will also think, okay, there might be machineries here which I might not want to invest myself. So then they can come back to university and tell, maybe I'm thinking to build a drone that works on stealth technology. So can you do it for me? I might not have a lab for that at my company. So maybe the university will do it. And the most important part, if your first, second, third, and fourth graded students can work on a live project of a startup or a company actually solving a real problem. For example, when we came into this segment, and when I was, so we were fortunate enough to go on Shark Tank India, right? So the only question that Aman asked me was, what is the difference between a plane and a drone? I'm telling you the extent of drone, what it has got. And at that particular moment, my answer was plane goes like this and drone goes like this, right? Sorry, other way around. So plane goes like this and drone goes like this. And that was all laugh around there. But you can see the kind of craze that is around drones as of now. And if you can include academia and industry together, we can do wonders. Because I can still see the industry segment. I still have a bunch of founders with me who have a lot of ideas, but ultimately they still have to get components from China or get a ready-made drone from China, and they fly it here, earn their money, and get their business. There is still very less development in terms of our own electronic components manufacturing because it is hard. We understand that. Now the government is putting a lot of funds. They have PLI in place, but academia can do it a lot faster if we integrate it with universities and make a very clear pathway of, let's say, a 5-year agreement or a 10-year agreement or maybe 20 years engagement of how we can actually utilize each other's skills. We can go a very long way. Thank you. Over to you.
So the thing is, like, it's very grateful to be here, and thanks to the panelists and organizers and all of the students as well. So initially, when I was starting my business in 2018, and before that, working in manufacturing and working in other companies, studying like you, getting into college every day and doing things for the professors. Basically, I'm not disrespecting anyone, but initially we thought like we were doing all these things for the professors, for the institutions or the managements, but it is actually for our growth. Initially, I didn't have this perspective, wide range of ideas how to get into the industry, how industry functions. Initially, we all have that kind of mindset saying कि okay, ये तो आज पढ़ना है, फिर कल मुझे exam देना है, then I need to finish all this stuff and I will be like sleeping for 8 hours after college. Okay, तो वो थोड़ा सा हमको amazing लगता है कि हाँ चलो ऐसा ही life होगा, but the moment you complete your college, get into taking all the responsibilities of the family and all this, I think we all feel and also understand the burden that we hold right now, we hold for the future, we hold for our family. At the same time, I want you to feel like you guys, when we say like you guys are the future of our country, you also hold a certain kind of responsibility for the country as well. There is a very specific moment I would like to share. Every single day in our college, we used to have national anthem as a culture of prayer. I don't know, like whether is there any other college those who are doing a prayer session every morning or not, because it is not so cool. It is not so like we say Gen Z oriented, but we do have this kind of culture because most of my instructors are from Indian Air Force, and most of my management people, they are also very much enthusiastic towards military and towards the nation. So we used to do the national anthem every day, and that essence that you do every day and that involves in your day-to-day life, that drives. Okay.
Oh, okay. We welcome our respected Vice Chancellor, ma'am. Please come.
Yeah, sure.
Thank you so very much.
So I was talking about my college life. I hope it is not boring. So coming to that, so that involves and that creates a very charming experience, and also that was the seed for me to getting into defense industry. Initially, I worked into civil aircrafts and multiple aerodromes in India. Understanding that also expanded my thoughts about how aerospace industry works. Coming to defense, it gave me a wide range of perspective towards how to build a business, how this thing works, how that thing works, and there are multiple layers to it. You can ask multiple questions like why you own multiple companies. There are different format of doing businesses. If you guys are willing to do any business, then most welcome to the industry, and you can actually find a sweet point or sweet part of the industry where you can work on. And if you want to be an industry expert, or don't feel it like a doing a business is a kind of an excuse to leave or to separate ourselves from the 9 to 5 job. It is not boring. I have done my 9 to 5 job and I have enjoyed the life actually. There is no difference between doing something for a company and doing something for my business. It is more of a like working 24/7 while doing a business, but more or less while being an employee or doing a job, it is like working 9 to 5, and apart from the 9 to 5, you still think how to solve the problem or the task that I have assigned to. Because while I was an employee to a company, and also I speak to my team members as well, like what you guys do when you are at home completing your day-to-day life in my office, and what exactly you feel about your work, because that is somehow needed when you go out there in the industry and build your own business. It is very important to mind your business, how it is operating, and also it is very much important to mind about your employee as well, your team member as well, like how they are doing, both mentally, physically, and also how they are doing in terms of understanding the concept of what is your vision is, because your vision has to transform into a doable manner to the employees. If I tell that I'm going to build a 5G drone enabling different kind of multiple stealth technology, which will deliver this kind of stuff to the military defense, and it will enhance the security capability of the country. But I just said all the entire business perspective in just one sentence, but there are more than 100 aspects to work on. Technically, business aspect, and there are multiple other. So I will conclude my thoughts right here, putting there is a to be continued mark so that you can actually work on that. You can understand your team members if you are founding a team right now. You can understand yourself fitting into a segment and choosing your own career path. Apart from that, while closing my thoughts, I would like to share a very small poem that I have wrote while starting my company. If they ask like, Ashish, what is the people knows me like AKB. Okay, sorry. So the user asks like AKB, what is exactly the driving force, or what exactly motivates you? So I start reading my poem as like while doing my entrepreneurship in 2017. I wrote this. So I hope you guys will listen it carefully. So it is about something like that. Okay. Day will come when I'll take the rest of my share. My vision lies on my eyes like a charming layer. My success is within me. I just need to feel myself. I wanna work for me, not for someone else. Tease me, make fun of me as much as you can. I said, day will come and you'll be proud of this. You'll be proud of this common man. My story will start a giant success stream. People will read about me with eyes full of dreams. All will have only words about what I did. But let me tell you, I have planned all this when I was a kid. Many times I failed, but still I'm out of fear. My reign has just begun, and you can't stop my watch because I am an entrepreneur. I am an entrepreneur. I am an entrepreneur. Thank you.
Thank you, AKB. Before that, I'm warmly welcome our beloved Vice Chancellor, Dr. Balwinder Suklaji, ma'am. And before.
Very good afternoon to all of you. Good afternoon, students. I'm really delighted to be here, amidst of the stalwarts on the dais as well as online. And I was going through the profile of each one of you. You're great, motivated, great inspirational leaders who have shown their matching in your respective organization through innovation. And AKB, when you were sharing your story, it's really amazing to say, and especially the poem which you have, or the narrated that what is your dream and your vision. I'm so happy and delighted to see my own alumni Jayant here. And it's always to see when the students start their own venture. It's not that the students who go for the corporate career, they are no less, but starting the own venture and succeeding in that, and that in the new technologies is amazing. And that's what our honorable greatest entrepreneur of India, the education entrepreneur, Dr. Ashok Chauhan, who had the number of industries, but I think the largest education provider, not only within the country, but in the 16 countries across the globe. I think that's the inspiration and motivation for every American, that the seeds of entrepreneurs, they are there in every program, in every institution, every campus. And today I'm so happy and delighted that we are having almost 150 speakers are going to speak today in sessions across the campus, and I'm going to each session for a few minutes. When we talk about the drone technologies, I think we are not going to only solve problems. I think the main aspects to take any industry, the drone are going to play a very important role, starting from the defense to agriculture. So it is from the India to the most advanced and the borders of the country. And I'm going to play very seeing that how so many examples. I remember 2 years back for Agritech conference and the exhibition, and we saw that how the so many banks are carrying the load, and also the fertilizers, so many things for the pesticides, so many things for them. Today also the Saturn Expo, we are seeing the one of the drone companies. Look at the difference. We are saying that how at the borders, whether internal security or the external security, how the drones are playing so important. So I'm extremely thankful to the HOI, Dr. Sanjay Singh, for choosing this theme for this conference and inviting such a great speakers. And this is for all of your students sitting here. We have to show that what we can create. I'm giving all kinds of attention to the students, all kinds of the support, right from the having the entrepreneurship awareness camp that we found, to the entrepreneurship, selling the within the institution, Amity Center for Entrepreneurship Development at the university level, Amity Innovation and Design Center, that if you want to design this end, finding Amity innovation incubator, where you can incubate your company, but we are the successful in the progressive entrepreneurship development in the university, and even if you have to develop some technology and you have somebody else to take the technology. So we have the technology transfer department, the IT department, so whole ecosystem is available to all of you. There is something else we should have. How do you utilize the 24 hours? Have the sound sleep, which is very important for health and for the creative ideas. And remember, after the classes, whether you spend your time on this mobile chatting with the various people and doing nothing, or you spending that time for the finding the new idea, working on that idea. As a team together, maybe 5-6 students were under the guidance of the faculty, we will do the guidance. And communicating with the industry, the kind of the speakers we are having today, the kind of the communication or the partnership of Amity has, we can take full advantage of it. So I'm extremely thankful to all our distinguished, the panelists, your presence here is not only helping the Amity University, its students, motivating them, but also we like to help you. And often we really need help from Amity. Contact with the interns or finding share your problems with us. Our team of faculty, our team of students will work on your problems, and if you take a solution, take it. If you don't like the solution, still that will give the learning to the students. And also we need your support because together we can develop that talent which can contribute to the economic development of the nation of India, what our honorable Prime Minister has been doing by 2037, we need to be the fully reliant, self-reliant nation. And our honorable founder president said that India will be the superpower, and that will be through research, innovation, and beyond. Because we cannot ignore the society. Society is very important, to integral part of the. How can we work together for the upliftment of the society? So thank you very much for your presence, and it inspires and motivates us. Thank you so very much.
Thank you, ma'am, for sharing your views and motivating all of us today. I will ask one question.
Good morning. Good morning. Good morning. Good morning. So correction is always required, right? It took 3 times, but we finally got there. Huh? Very quickly, 2 things which man said. One I had already covered, which was the seed. She said the seed of entrepreneurship lies with you. The nurturing elements are all here. You are the gardener and you are the seed. The second thing which I missed telling, but now after she said YouTube and the mobile, how many of you know how you define currency? Can somebody very quickly, how do you define currency? What is currency? Arey, brilliant. So not a country, anybody deals with. If I have currency, it could be dollars, rupees, gold, whatever. Perfect. So value. Let's focus on the value. So it has got something which has got value, which I can trade for something else, which has got a parallel higher or a lower value, right? What is the currency you have, which I don't have probably, and some of us we don't have. AKP has time. So I have my son who's in class 8, right? So I was telling him this. What is the currency you have? You have to be only bothered about the currency which is time. Now, if I have 5,000 rupees, I have made a bad choice of buying something which is not a good product. What I will do, I will throw that product one. I'll earn 10,000 rupees and then go and buy something which is worth 10,000 and probably to make me happy. I want to buy an Apple phone, I'll probably earn 1 lakh, I can earn, right? I can work hard, I can innovate, I can do all that. But the time spent, can I earn it back? Can I get it back? So the time spent on Facebook, WhatsApp is your currency, right? If you are spending your currency well, which she said very nicely, you sleep well, that means you have spent your currency right. You know, you have helped the body to be active and able to create something in your mind. But if you slept late, you got up late, and when you got on WhatsApp, I miss the class, your currency is well spent or just spent, and it is not going to come back. So use your currency well. Every time you do something, just imagine this is your currency. Would you want to give your money 100 rupees just like that for a bad product, for a product which is not worth it? Not even 10 rupees, not 100. So your currency, which is so extremely invaluable, you have to be the best just to use that. So henceforth, every time you do something, just give it 1 second, say, this is my currency, am I spending it well? Yes, no. Answer is no, stop doing it. Answer is yes, continue doing it. But be intelligent about it. Okay? Thank you.
Thank you. So, before going to the next panelist, I do have one specific question to the AKB. Could you please highlight what are the untouched domain of the Indian drone market?
Speak about the things that are untouched right now. Multiple stuff has already happened in the drone industry. Or this, we can say
in last half of the day, initially we see the development of the drone industry of the ecosystem. Basically from 2015 or 16, when the drone parts and all these things came up to India, or from maybe from China, or maybe from other countries, and people started building their maybe binary project or building their businesses around the drone technology. Initially, they started with quadcopter, then octacopter, then sexacopter. There are multiple nuances to that. Then people will build up helicopter with some automation. There are very brilliant people from IIT Kanpur. They build an helicopter for DRDO and all this kind of things. Now, when we talk about drone delivery or doing any sort of, I think people are including or contributing their thoughts into what we can do into drone, drone into the industry, like aerial surveillance, delivering something, doing some aerial operation, flower logistic and all.
Yes.
Apart from all this, what is heading to? What is the next after drone? If we have something in the drone industry and it is still on growing stage, and it is definitely going to be a billion-dollar industry. Okay, that's the mic.
Yes, sir.
So when we talk about like the drone is right there, let's say this is my drone and I'm doing something with this, and there are multiple other businesses, those are doing maybe the same thing, they might be doing something different thing, but doing in the drone industry. Why I chose to speak on this particular thing, which is little bit of untouched industry in India, because what is next in the drone is people are looking forward to travel with the drone from urban mobility, right? There is a very niche area which is right now finding its way to enter Indian market, maybe Indian civil market and also multiple other. Let's say my location coming to this, just think about this scenario. The airport is like 30 kilometers away from this location, and I have to commute myself from airport to your campus. If I'll come by cab, it will take almost around 1.5 hours. Am I right? Yes. So if I'll take a urban air mobility, which is I think Blade India is doing in Bangalore and multiple other locations. Recently, I took a Blade India aircraft flight from airport, Bangalore airport to ICEIL airport. It cost me around 4,000 rupees, which is very reasonable, and the cab was taking like 2,800. I can pay another $1,000 or 1 grand or something like that, and I will definitely go with my aircraft, and I'll be like 15-20 minutes it takes. So coming from helicopter to operate for urban air mobility, it will be more lucrative for a business to do it with the drone, or maybe air taxi you can call. There are multiple companies in Middle East, and I think there are multiple companies, those have already experimented on this particular topic, doing air taxi operations. So when we talk about air taxi operations, recently I came to know about a technology which is air traffic management system. It has been developed by Rafael company. It is a defense company, but they are building a software solution for air traffic control management system, which is called Metrodome. Okay, Metrodome. I don't know why, how did they came up with this name? Because if we say Metrodome, it sounds like we are putting total Rajiv Chowk into a dome. Okay, so when we talk about Metrodome, it connects the civil drones, like it might be delivering your food from Zepto or Swiggy, and also it talks or interact with any air taxi around the airspace, and also it talks with helicopters flying below 1,000 feet. It also communicates with local ATC and also the A320 or A330 like airliner aircrafts that are about to, those are in the approach, or they are doing their they are below the top of descent. So these are the technology which is happening right now, and I got to know like there is a company in Delhi. They are also building something similar product for air traffic management system. Coming to that, what is the most pain point to the air traffic management system is like you can get like air traffic management system which is still untouched in Indian industry in terms of drone and the air taxi management. Then the traffic collision and avoidance system. It is a very niche and a very prolific technology which has been built by multiple aircraft industries like aircraft companies like Airbus and Boeing and multiple other. but it is not introduced for a miniaturization of the same technology for drone or air taxis. Okay. There are communication linkages. You can go up to 5G, but there are some environmental impact to that as well. We can move around the stuff and we can work on that as well. I come to know about another technology which is talking about and eliminating SATCOM, the satellite communication, and they are going to do the communication through a laser-based communication, which is like in light speed, and it can happen from one single medium and it can deliver the job. There are multiple nuances where things are untouched, like C4 ISR system, which is very, I think, very niche, and also it has been touched in defense industry. It has been explored very minutely, I would say, but it is yet to be, broadly explored. Right now, in my company, we are working on a C3 ISR, which is command, control, and compute. You can work on command, control, communication, compute, and then surveillance systems. So these are a few points. I hope you have made a note of it, or else, okay, there might be any other time on top of which we can discuss all these things pretty elaborately. But these are the some untouchable, untouched market or the segments of the drone industry where we should, I think, look upward.
Thank you. I do have one small correction on your comment. You made some comment that IIT brilliance are from IITs, but I wanted to make a correction that brilliant students are in Amity also.
Absolutely.
No,
I actually,
yeah, because I was expecting what I wanted to say that I was seeing some Facebook posting, LinkedIn posting. Students are commenting comments than the professors of IIT. What I wanted to make it clear that because every questions is saying when you are sitting Amity or San or IIT, other women students are so you should focus silent institution for collaboration. When students are high and next week we are going to file a patent on another concept. So that you should constantly interact with us and get our knowledge. We are having dedicated students here. This is my comment, sir. That is my comments. Yeah. One other thing I come that I'm from IIC. I experience teachers, but I'm also that we are not good teachers, but good researchers. But we need good teachers in our country. That is lacking.
absolutely.
We need good teachers in all institutions. I'm going to address to the minister that teachers should be the top in the world.
That's right, sir. That's right, sir.
What is the energy equation?
Energy equation.
I don't want to see all more raised hands, otherwise I'll take one.
So what we learn constant. We can solve that control university. It's also university.
So the who all knows what is energy equation? So now go and use your currency well. He has given brilliant ideas as to what all the potentials are. I've only given you the idea that seed is there, sir is said teachers are there. You want to see, go and at least find out what is the energy equation, what does it mean? Then how does it apply? What he's not get talked of artificial intelligence into the drone mechanism. Where all these aircraft and traffic management systems, will all be integrated. Now that's the big tree with lot of fruits.
The big tree with lot of fruits, right? Artificial intelligence with data science, with mapping of the drones, with the whole airspace, because ultimately the airspace is also restricted with the commercial traffic around it. And if you're talking of hundreds and thousands of drones, that means we are going to be with a very limited airspace. That means we will need a system to manage that automatically. It will be not possible humanly. ATC controller will not be able to see on the radar 10,000 or 5,000 drones flying over at different levels, doing different tasks, landing, taking off. They will not know. So it will be an automated system. Means what? Artificial intelligence will kick in. Means what? A different type of software integration will happen. That means what? The hardware component itself will see a different shape. So hardware, then the human who is developing is also going to be of a different level, which sir said. The student has to bring that value in. Teacher has already taught, but you have to figure out there are so many fruits around the drone industry. And I already told you it's going to be $1 billion industry in India itself in a couple of years from now. In 2030, Government of India forecast that will be the global hub. What are the avenues are? This session is too short to do that. Use your currency well, use the expertise of the people around, make best use of the support system which you have here. I think that is the goal, right? My 2 bits. Thank you so much.
Thank you.
To add one thing, basically, how many of you know AAI? What is AAI? Can somebody say?
AI.
Airport Authority of India. So basically, till now, see, agency said ATC and all. So air traffic management. Do you know almost what equipment constitute ATC? What are there? So you have your voice control and command system. Basically, the aircraft needs to communicate to the tower. The tower needs to communicate with the in-house, basically ground to ground or ground to air. So this type of communication. Then basically ground to air, how we are doing. So you have your radios. So till now in India, everything was imported. In civil world, in defense side, we were doing it. So in defense side, like VCCS was being manufactured by a company called AEM in India. Tata was doing all India has almost for 76 your defense, your airport managed by Navy and Air Force and also. But in civil side also, why I said AAI had just opened a institute or a R&D organization called CARO, CARO. And they are inviting startups and young innovators like you to come, go meet them. They have multiple opportunities. They want to Indianize the VCCS system. They want to Indianize the communication system, the telemetry system and all. And they have a lot of opportunities there. So if you have some interest, you can go and you can. And Caro is situated in the AI headquarters in, I think, near Jorbagh metro station. So you can go meet there, or you can write, you can get, I can connect you if somebody is interested.
I request Jackson, the program manager, R&D, welcome technologies to deliver this talk and share your thoughts. Over to Jensen.
Yeah. I can, hello. Good afternoon all. First of all, I'd like to thank Aerospace Department of Amity University for giving me this opportunity to share my thoughts. Starting with, I would like to say a few things like opportunity. That today's theme was development of drone industry and startups for the future. See, if I look into the future, the things are going to be unmanned. When I say unmanned, it's not only restricted to air vehicle, it will also include the ground vehicles, like you call it UGV, unmanned ground vehicles. Okay, warfare. Now today we humans are fighting, but maybe in future it will be the war between the artificial intelligence. Robots will be fighting the war for us. Unmanned ground vehicles will be there on the battlefield. UAVs will be will do the firing part. Okay, UAVs will launch the missiles. So when I say unmanned systems, so I will rather talk about the unmanned systems. So it is a huge domain. Now, even what we are considering so far was on the ground, on the air. Now, what about the underwater systems? Can you have unmanned water systems? Maybe in future we can have that. Okay. So talking about the development or the progress of this unmanned system and the unmanned industry, it has got a huge potential, mainly for the startups, mainly for the existing company, and the people like you who are sitting over there, the young students who tomorrow can take up these challenges. See, UAV industry is full of challenges. Like before me, the speakers like Vivek Pandey, then AKB, our sir, Acharya sir, sorry. Acharya sir said that there are many challenges. Now, if I take the point you from AKB, there are multiple line items. When you talk about the drone industry, there are multiple line items that goes into it. Okay. Now, what is the role that you people can play right now? Because you are in second year and third year, you have done some education. You have gone through aerodynamics, you have gone to design, you have gone through thermodynamics. Now, also being a part of the academic institution, the component level R&D should start with you. Okay. Being a company, see, every startup in India has certain limitations.
startups, when I say startups, we cannot talk about the amount of funding which Tata, L&T, or let's say Adani has. Okay, there are many startups who are working with small package of fund. Okay, in that case, they cannot employ 100 or 200 employees and start the R&D work. Okay, in that case, the companies can become the end user. If I say UAV, can you think how many component has gone into it? Until unless you are part of that R&D, you won't understand. Like when, if I talk about in our case, when you started this project on TBRL, there was something on paper. And when we started physically fabricating it, the world was different. Like Vivek sir must have told you the challenges. We have spent many sleepless nights thinking about the component that will go into it. Okay. Now, what are the challenges in component? Try to understand this part. Whenever you are doing some R&D or whenever you are doing or developing some product, that always come with certain specifications, certain weight constraints, temperature constraint, like he said, minus 32 plus 70 degrees Celsius. Okay. Now, a company, like say, if I say is a MSME company, they cannot afford to do R&D where they are developing a camera that can operate at that temperature. Okay, it's not possible at that end. But with the workforce that Amity has got, in the department, you can do that R&D. You can develop sensor. You can develop the autopilot. Okay. Now, if you those who are into aero modeling labs, they must know what are the different type of autopilot available. Okay. They are mainly open source. Different companies has customized it and now they are using under different brand names. So the challenges come when you have completely new system to use. Like for example, let's say I want my typical autopilots from USA that comes with 12 pins. But for my system, I need 14 pins. What can I do? Where I'll search that? Okay. Let's say I need my field of view to be 80 degrees, but the existing camera in the market, they have got 65 degrees field of view. Then what I'll do? So this type of R&Ds can be taken up by you people. Okay. One more thing I would like to highlight, the manufacturing part, the composite part. Okay, still the understanding of composite in India is quite limited. When I go for finite element analysis, I find that I get multiple profile where they have worked lot of work on steel, aluminum, alloys, this and that. Okay, but what about the composites? Still, if I talk about the ANSYS, even that big company ANSYS, they couldn't find a proper profile for the structural analysis. Why? Because you don't have proper Young's modulus to be defined. Now, when you talk about the composite, depending upon the orientation of the fabric, property varies. Now, what you have to do, you have to test then each and every fabric. You have to test each and every resin that you are using with the fabric. So this kind of R&Ds can be taken up by the educational institutes. Okay. So mainly you should focus more than thinking of the drone as a system. Institutes must focus on the component level development. Battery, very important part. Okay, now when I talk about the battery, the requirement of battery at high altitude and low altitude are different, because if I take my LiPo battery to the altitude of, let's say, 4,600 meters, 5,000 meters, they tend to swell. Okay, and I hope you know the battery performance. Most of the LiPo, lithium polymer, lithium ion batteries, they operate good at 10 degrees Celsius, the ideal temperature. Okay, but if I have to use the same battery at minus 30 degrees Celsius, how can I use that? Right. Now, if I have to use, now if I talk about the basic level electrical wires, okay, that AWG rating come, gauges come. Now, what about those wires? Can you have a wire that can operate perfectly at minus 50 degrees Celsius? Can I have a wire that can operate at 125 degrees Celsius? Answer is yes. For the high temperature, yes. But what about the low temperatures? Next, speaking about differences. Around 16,000 feet and a soldier is sitting at 19,000 feet. Even if you look at that altitude, you can understand, you will feel the challenges it has got. I was there in July, and that time already there was a snow cover. Secondly, if you are operating at that region, the challenge is how you breathe there. Because if I am walking for, let's say, 10 meters, I started feeling breathless. Okay. Now, this is a new challenge. Like somebody asked, what are the new challenges? Now, providing logistic support, developing the logistic drone for those altitude is a new challenges we have got. And if you can solve it, I can tell you many lives can be saved. Okay. Now, apart from that, I would also like to highlight few points because you people tomorrow are going to be a new age entrepreneur. Now, when you start your entrepreneurship journey, we also told you about some of the standards that you must learn, that you must follow, like just Pinta 5, MIL 10G. So when I entered this industry, I was unaware of all these standards, but I have to study, I have to read them. Okay. Now, talking about some of the challenges that you may face, that will be, and even we people are facing, that is the regulation challenges. Okay. Government agencies like CIMILAC, DGQA, Quality Council of India, DGCA, they are there and they are the regulatory bodies. So whatever you are building, you have to get that certified by them. Without that certification, your product has no meaning in the market. Okay. Now the challenge is how you can understand their requirement. How can you comply to their requirement? Okay. Second point is testing facilities. Now today, even as a startup, what you feel the challenge is the testing facility. I have developed a system. I have developed a drone. Where I am going to test it? If I have to test, if I'm claiming that my drone can fly for 1 hour, where can I fly my drone? See, the requirement for quadcopter and fixed wing is different. In fixed wing, you need certain radius, certain, let's say around 5 kilometer, 10 kilometer range to test your system. Where can you get that? It takes a lot of time to get the clearances. Okay. Next is policies. The multiple government policies, which I believe, like, see, over the time it has been liberalized, but certain level of handholding is also required. Okay. Next is training. Now, as I'm working with DRDO right now, so what I can see that I'm getting a lot of exposure while interacting with them. This was not a story long back. Okay. Now there's a certain level of handholding provided by your DRDO. They have opened their testing facility for us. They have opened their knowledge, the knowledge they have accumulated over multiple decades to us. Okay. So now these are few positive things that has developed over the year, which can be taken advantage by you people. Even I can see on magazines or newspaper, I can see multiple opening of internships or training programs with DRDO ISRO are open. Okay. You must visit that. Okay. And the challenge as an entrepreneur you may face is the seed funding. Certain level of, again, handholding financially from the government. Okay. And another thing I would like to point, like, since you people are now in the college, you have to take all your concepts or the topic that you're learning seriously. When you talk about aircraft design is not a something that can be taught in the classroom. Okay. More than the classroom thing, you have to explore yourself. Because when you go to design, you'll find that few things you are qualifying and there are multiple things you are not qualifying. First is the weight. When you think of doing something ruggedized, okay, something very strong, you will cross that weight requirement. Okay. So whatever thing you are learning at your college level, please take them seriously and try to explore it. Don't keep you limited to what Sanjay sir is giving you as an assignment. Go beyond that. Okay. Push him. You also push him. Sir, I have taken up this problem. Help me to solve it. And I'm telling you, autopilot is a big challenge. Sir is working on neural network. Okay. Take help from him. Develop that skill. Okay. And one more point that my other speaker said, artificial intelligence. Guys, future is there. That's it. Okay. So that's all from my side. Thank you.
Thank you, Jen Singer. Because of the short of time, I request to the audience 1 or 2 questions to the panelists. We can have some discussion. I think wonderful.
Hello everyone, my name is Sanjam Bhadwaj and I'm in BTech CSE, IoT and Cybersecurity first year. And I had a question to AKB sir right there. I wanted to ask you, how can we integrate cybersecurity into drone technology?
Okay, speaking of that, cybersecurity comes into play and security comes into play when there is a question of confidentiality of the physical structure or the information that we are
Processing or delivering or transporting. Okay. Coming to the military industry, when we operate a drone, okay, I will start it from that perspective, then we'll walk into the cybersecurity, how it can be useful. So when we operate a drone, there are multiple stuff which is associated with the mission planning as well. So drone is flying up there at some altitude. There is a ground station, which is a command and control center. It can be mobile, it can be fixed. It can be mobile and it can be fixed. Right after that, there will be another person who will be having a ruggedized laptop. He will be somewhere, he will be just looking at the feed that are coming from the drone. Now, all that operation, I hope you might have heard of, there is a Iranian military aircraft that shut down a MQ-9 Reaper very recently. The Reaper encroached the airspace of Iran, and right after that, the MQ-9 Reaper fell down, and USA, like every time, he just denied the fact that it has shut down. So now all this operation, all this information that are going, let's say there was a MQ-9 Reaper which was flying on that Iranian airspace. So he was definitely taking some information which is coming under the surveillance purpose. So all that information that are transmitted from one part of the world to another part of the world, don't you think that it is classified? It is. So that is where the total information transmission has to be protected through a specific way of communication of the network linkages. Coming to the cybersecurity application, there are multiple nuances where I think recently, if you guys can go to IDX, Innovation for Defense Excellence website, which has been operated by DIO, Defense Innovation Organization, they have put across our problem statements only about cybersecurity in disk 7, Defense Innovation Startup Challenges. Okay. So in disk 7, they have came up with 19 to 20 problem statements about cybersecurity, starting from quantum computing, coming to the military personnel's attendance record. Everything is classified. I should not reveal the fact that how many Javans right there on my border defending my line of action, defending my country. So all that thing, everything is right now on paper and registering onto a specific paper format. Everything that has to be go through the cybersecurity and the security stuff. So I think like that you can explore the problem statement that the current market has, and you can go up to like any different label that you can come across. That's what from my side.
Thank you, sir.
Thank you all panelists and speakers. It's my duty to give the vote of thanks, sir. Please bear with me. I stand before you today with a heart gratitude and sense of appreciation. As we come to the close of this enlightening session, it is my privilege and honor to extend thanks on behalf of the Amit University, Uttar Pradesh, particularly Amit Institute of Aerospace Engineering, for making this event a resounding success. First and foremost, I would like to express our deepest gratitude to our wonderful Honorable President, Honorable Chancellor, sir, Honorable Vice Chancellor now, and our heartfelt thanks go out to our section chair, Mr. Ashwin Acharya, for moderating the proceedings, grades and expertise. Sir, your contribution has been invaluable in the flow of this section. I would like to express our sincere gratitude to our distinguished speakers, namely Mr. Vaishnav, Mr. Vivek Kumar Pandey, Mr. Ashish Kumar, AKB. I'm sorry if I make you some comments on that. And Mr. Jain Singha for sharing their knowledge and insight. Your perspectives have been enriched our understanding and led to the results of the mark and lines. A round of applause for our section in charge, respected Dr. Sanjay Singh, sir, Director AIU, for his exceptional guidance and support in organizing this event seamlessly. A big thanks to our section coordinator, Dr. Saluja, sir, for his meticulous planning and coordination. which has been a backbone for this event. We also extend a gratitude to our dedicated faculty members, Dr. Neeraj and Dr. Jeevan Rao, for the continuous support and mentorship to our students. And heartfelt thanks to our students, volunteers, Ria, Akshita, Madhav, Akhil, Bhavya, Lipanshi, Nasik, Anurag, Prince, Harman, and so others for their tireless efforts in assisting us in organizing this event seamlessly. We also want to extend our appreciation to our photography team, Rhythm and Siva Subramaniam, for capturing the moments and their foremost remind us in this wonderful section. A special mention goes to our IT team and admin team, who's behind the scene effort to ensure the smooth functioning of this event to slight disturbance. Our gratitude extends to our office staff, Mr. V. Mehta, Mr. Manoj, for the administrative support, which is often the undo of such events. And special thanks to my colleagues and all faculty members of our Amity Institute. Last but not least, thank you all for the audience for the continuous support, patience, and dedication. We look forward to for more enlightening sections in the future. Thank you all. Have a wonderful day ahead. Thank you.
So thank you, audience, for your patience. You have, I hope you all have got many takeaways, right? And please utilize all these knowledge that you have got today, right? We wish you all the very best, and we are always here to help you out with whatever endeavor you follow. Thank you, and thank you. I would especially thank Mr. Vaishnav for joining online. Right, you have been there. We miss you offline. Someday we might be, have a chance that you meet our students face to face. Thank you so much for joining.
Thank you.
So, very good afternoon, one and all present here. I, Dr. Suchismita Mishra from Amity Institute of Space Science and Technology, Amity University. Welcome you all in this session, exploring opportunities for startups in space domain. In the 5th International Conference on Entrepreneurship, Innovation and Leadership, with the theme, Next Gen Tools and Strategies for Business Growth in Industry 5.0. In this session, we have a panel of distinguished speakers from the domain of space sector with us. I'm sure that talk would enlighten our students and research fellow on different aspects of emerging opportunities for space startup. Now, I would like to request Professor M.S. Prasad, HOI, Amity Institute of Space Science and Technology, Amity University, to present a sapling to Dr. Virendra Goswami, sir, who will be chairing the session today. Now, we welcome Mr. Anup Srivastava, Head of Electromechanical System Section in Spacecraft Mechanics Group, URSC. So we welcome you, sir. Thank you. And next, we welcome Mr. Avinash Marmaraju, Vice President, University Space Mission, Dhruva Space Private Limited. We welcome you, sir. Now, we welcome Mr. Vaibhav Kumar with us. He is CEO of Aerobotics TechSoft and Aerocart India. Welcome you, sir.
Hello, ma'am. Very good afternoon.
Okay. Now, I request Dr. Shivani Verma ma'am to present a sapling to Professor M.S. Prasad sir, HOI, AISST, Amity University. Okay.
So I'd like to request Professor Ramesh Prasad, sir, session in charge and moderator, to share his thoughts with us. Sir, please.
Good afternoon, everybody. Can you hear me? I think it's little this. I would like first to thank Dr. Birendra Goswami. I'm really grateful for finding time to come on a very short notice. And also, the other speakers who are joining online, especially I know the busy schedule of Mr. Marmaju, lot of business deals and other. But I would request the audience to listen to him because he is the largest startup in the space science. I would also like to thank Anup Srivastav, who is in ISRO, and he has got a lot of other meetings, so I've scheduled it differently. One of the biggest, drone and the robot startup and doing very well, Mr. Vaibhav Sharma. Thank you very much for finding time to join us, at least online. We are really grateful for all of you to devote time to us and come back, give us your insight in what is the condition of the startups in the space sector. You want me to say something? Yeah. If you look into this problem, that why we are having this session, you look at our system, slowly our country is moving towards, keeping a foothold in the space. Chandrayaan, Aditya is a remarkable outfit. Mangalyaan was another, goal which we achieved in the first time. What it means that now the space is not limited to ISRO and a couple of organizations attached with it. Our Honorable Prime Minister wants an open up Indian space organization whose job is only to promote startups and new companies. In fact, I was talking to one of their directors and he said, by December 2022, there are 112 startups who have come in a space domain itself. Out of that, 15 to 20 are doing very good. Very well. Like I said, Dhruva Space Company who are there, look at the performance they are doing. So now the question comes that we have an opportunity. Please do not think that the space systems are extremely complex and I cannot be a part of it. No. There are small things and small things. I know it's a conjecture of large number of, engineering domain. But all of you, the new people, can start up small and come to the bigger thing. One of the biggest problem all of you are being taught is space debris removal or management. All of you can contribute in that. We require a lot of a startup to come into that and find out how to do that. It's a normal problem. Recently, one of the Manestu or some company has come up. They are trying to do how to escape debris pollution. Recently, very recently, this company has come and I had the opportunity to see their this thing. You can work in, if you are good in electronics, find out how you can give a support. Gaganyaan. We are trying to send the human being into the space and it opens up large number of avenues for the young people to think and come out with some solution, some small solution, innovative solution. Invention, you do not take it. You think of how can we do innovative product, which can go into the space domain. And there are experts who are going to guide you. The way our Prime Minister is laying down the space policy and also a space activity bill, which is getting passed, you will find it is like opening up like Zomato and other company. There will be no hurdles for you if you want to work on, a startup and a space sector. I would really request all of you to put in a thought process in this and how to become a part of this space revolution. Also, please listen to the experts who are already given their due in this domain and what is their view. How can they collaborate and try to find out the point where you can converge and do something for the Indian space system. Thank you very much. Thank you.
Thank you very much, sir. We have distinguished speaker, Dr. Virendra Goswami, sir. Dr. Virendra Goswami, PhD from IIT Kharagpur, MS from the University of Wisconsin, USA, postdoctorate at the University of Illinois, Chicago, USA. He served as visiting scientist to United Nations Industrial Development Organization, ICTP, Italy. He is also expert panelist in International Civil Aviation Organization, Canada, and the United Nations, founder president of Environment and Peace Foundation, and retired wing commander with more than 550 hours of flying aircrew. Dr. Virendra Goswami worked at Space Science Engineer Center, NASA, National Oceanic Atmospheric Administration at the University of Wisconsin, USA, and former Vice Chancellor of Sangam and Sunrise Universities. He had more than 44 years of teaching, research, and administrative experience. So we request you, sir, to share your knowledge and thoughts with us. Sir, PPT is not.
Okay, so how much time you want me to speak?
Sir, PPT or PDF?
So,
Sir,
you just tell me
PPT is.
from here, I will keep on doing, or you. somebody
No,
going to
we,
check?
we have this PDF that you have sent us.
Yeah, that's good. Very good.
So we open it, this PDF is.
This okay? Then what, who is going to open? I will open it or somebody else?
Sir, you wish, sir, if.
अच्छा ठीक है
So मैं share कर देते हैं sir इसको.
तो आपको शेयर करना होगा ना वो
जी.
बढ़िया जो है
जी. ये share करो. जी, देखो.
ये बात
इसको हम चेंज करते रहेंगे ना फिर will help you to change the slide.
ये इसका थोड़ा ये साइज छोटा नहीं हो जाएगा ये काफी बड़ा नीचे का स्लाइड नजर नहीं
ये
आएगा
रहा कितना छोटा चाहिए सर आपको?
हाँ तो ये साइज हो जाए थोड़ा और बड़ा भी हो सकता है कोई बात नहीं बस ठीक है नहीं, इतना नहीं मतलब पूरी साइड आनी चाहिए थोड़ा और बड़ा कर दूं
ठीक है
बस
थोड़ा सा
काफी है, थोड़ा और करो बस आई थिंक दिस इज विजिबल टू एवरीबॉडी ओके
if you want to change this
और तो चेंज यहाँ से करना है कहाँ से करना चाहिए
आप एरो से डाउन करेंगे ना सर विल डू दिस हाँ
ओके Well, good afternoon to everybody. I'm seeing very young student and this gives me great pleasure that what presentation I have made that is purely meant for the young students and not for the young faculty to some extent, but not for the senior professors and the scientists working in this department because they will find it's very, very preliminary and basic. But our aim is not to teach or to give advice to the people who themselves are advisors. Our idea is to make the young brains, young minds, to that extent, whatever we could achieve, they should surpass us. I'm thankful that they read my brief, not that I have to get some job here, but it is the pleasure for any professor and your parents, of course. There are only two relations in the world They feel very happy when you overtake them. Nobody is happy when you overtake, but these are only two people. When you overtake them, it means when you surpass them, whatever little bit contribution we could do to the country, or to the whole global community, we wish that you should do much more. But how to do that? What effort has been made to tell you how to do, how to become scientists, especially the space scientists. So it's more of the things which you will find in the presentation is almost points, dot points, milestones. How should we become first a good human, a good student, a good teacher, and then only all teachers are not scientists. All professors are not scientists, but all scientists are good teachers and professors, no doubt. So, well, with this little introduction, I must tell you, because I have been very thankful to Professor Prasad, my old association. It is always a pleasure to be with him, and it's surprising, except the gray hair like me, he's the same what he used to be. And secondly, it was so courteous, Professor. I was talking all the time. Earlier also I had given one lecture in one of the conference. They invited me. That was on my very favorite subject, satellites, because that's a thing which we worked in the initial stage at NASA. That is Space Science Engineering Center, University of Wisconsin, which is the one part of NOAA and NASA laboratory. And I was very lucky to work with Professor Swami, Martin, and Sigdar. Well, I came to know very late that I am lucky to be with very world-renowned professors. That so happened. This I was working with them from 82 to 84, other 85, 3-4 years. And that time I did not know with whom I am working. You see, I only knew what I had to work and what I had to learn and what I had to acquire knowledge and take back to my country. I never had intention to stay. Not that I didn't like NASA, not that I didn't like country, but however, this was my feeling that after having acquiring the knowledge, this knowledge should be given to my country first, then anybody else. Anyhow, that happened exactly. So just coming to the point, I am very happy Dr. Prasad had given and Shivani a position of chairperson, and at the same time he asked me to be speaker, and out of humility when I asked how much time should I take, he said, sir, there's no time for you. I'm very thankful for this, because I'm very particular about time. If you give me 10 minutes, I'll speak 10 minutes. Give me 20 minutes, I will do 20 minutes, and let there be a little self-praise. 2017, when the alumnus of Moscow State University, they invited me in a very good, big conference. I was the only Indian professor who was invited for the 2 sessions. So one of my presentation on ecological transport system. First time we told them what is the ecological transport system, and that the Indian professor, by God guess that me, got the standing ovation from the Moscow State University. And the time was given to me, the 15 minutes, and that 14 minutes, 59 seconds, I finished my talk. And the vice chancellor, they called rectors there in Russia. So they said, thank you, Professor Goswami. We are very thankful, and you are the most disciplined speaker we have ever come across. So well, I need not to maintain any discipline, but still I will try to be as short as possible. And skipping the slides. The slides is one of the it's more of the it's a audio video presentation, because audio I myself and video will be the slides, and this is the best way to get a job in your minds, or absorption of the knowledge into the mind of the audience. That's the reason when you go to cinema, you remember the story for years together, because there's an audio visual system. See? Always think, why I'm telling you like this? This was answer. You think, why it is happening? What is this and how it happens? If you are able to answer these 3 questions of this, then you can become anything in your life what you want to be. Even the luck will go ahead in front of you, because God will be with you if you are working hard to pursue something. Anyhow, with this, a little, the motivations or those, whatever you call it. So I was talking, yes, 2015 only, when the NASA invited me again in one of the very big conference organized by World Meteorological Organization, United Nations, in Meteor-France. That is they call meteorological in France. It was there in the South France, beautiful city, Toulouse. So there you see, it's so happening. There only I came to know that with whom I worked, they were very big professor, and I was told the Jet Propulsion Laboratory of NASA in the honor of Professor Sobi has been given that Sobi Satellite Center. So this is a great pleasure to be in association with this professors. You know why this is pleasure? Not that you got the fellowship, not that you got the opportunity to work in that. The main thing you got the vibrations from these professors, and those vibrations scientifically have been proved when get into your neurological centers, to your optic nerve, to the neurological nerve, then at that time you also try to become like that, and you get motivation. And if you focus on that concentration, definitely you are going to get something out of that personality. That's why the attending conferences and meeting to the big people is very, very important, ladies and gentlemen. That's my experience, what I had. I will not talk anything else here which I have not experienced. Because neither I am a leader nor I am a minister. I will give you wrong or some assurance with a due apology. It's not that all ministers are like that. They are also good, some good people are there, but it's in general, I told you. Anyhow, so with this things, what now I come to the slide. In between, I will tell you the tidbits so that because this subject is very, very advanced and very difficult. And it's not that very interesting. Yes, the video is very interesting when the rocket is launched and is going up and all those things, and you're getting beautiful satellite pictures. It is a very beautiful subject it is, but when you are learning this subject, it's not that I mean easy कि लोग कहते हैं ना कोई rocket science थोड़ी है जो तुम्हारी समझ में नहीं आएगी. कहने का मतलब है कि rocket science is the most difficult and the advanced science, and your department, I must tell you, one of the most advanced and the highly erudite professors they must be having, because nobody can work in the space just like that. You have to have space in space. Okay? Anyhow, so with this, well, gentlemen, now I will quickly rush about slides. I will just tell you this is a topic what I was given, and I got little mixed up with the topic. कहाँ से करना बच्चे ये यहाँ से करना है? कोई बात नहीं, मैं कर लूँगा. हाँ ये. Well, I was very happy with the present what Dr. Prasad and they gave me this plant, because I am a rather founder director of Environment and Peace Foundation. That is registered in 2016. It is not only a WhatsApp group, it is meant for the young people and the young, I mean, when you call people, it includes all the genders. So to find out the innovative methods and technology to control the environmental pollution and control the climate change or the global warming, you see. So this group is meant, and is mostly the members are of scientists and the professors, retired vice chancellors, and other things. But everybody is welcome to join. So that time, about 7 years back, whenever I organize any conference, attended, I requested that in presence the plant presentation should be given as a memento. So that's very nice. They were very, very happy that they have a team. And this is the thing which I liked very much. So this today I will be speaking a computational kaleidoscope of leadership, innovation, and entrepreneurship. That we call very nice. You like it and you will like it. What you like is your same kaleidoscope of your leadership, innovation, and entrepreneurship. You all have seen in your childhood the kaleidoscope. So here I am trying to show you what is innovation, what is research, and what is entrepreneurship. And after which is what is, then why it is. And the third question, what I have said, how it is. It's very, you see, I remember my student days. Of course, I was very lucky studying in the good institutes, IIT, Wisconsin, all these places. But yes, in a school time, I know, माँ बाप भी कहते थे, टीचर भी कहता था, खूब पढ़ाई करो, अच्छे नंबर लाओ, डिवीजन लेके आओ. तो कोई ये नहीं बताता था कि कैसे पढ़ाई करो. Nobody tells you how to study, how to read a particular subject. Anyhow, so this is what my effort is for the youngsters. My due apology to the senior faculty if they are attending online, because it will be little basic. I like your this caption which you have made, that you started this space. This is a conference sometime in 2018, and now it is the 5th. So I really, this is the innovation. This is the practical example of innovation by you people. This is not given in any Google or anywhere. And then the second following of your innovation is research. That is, I use that your caption. Okay, that's how. When you do improvement something, you see. Innovate means new word from Latin word, innovate. Something you do in a different way. Research. You are such. What is such? Not go by dictionary meaning. It means acquiring the knowledge. In general, if you see the meaning or the context of research. Now, why I'm telling you this, because I can be without slides also, because during Vice Chancellor Day, the other day you had a secretarial staff, so there was no problem. Somebody making PPT for you, somebody is doing for you. But now everything I have made myself, so it is on my fingertips. So, but slides I have just made you for your video, visual and audio consultation. That's the only aim. So anyhow, some of the things I'm speaking, which you are not seeing in the present slide, it will be I will passing to the slides. Okay. So now quickly I'm coming on the you see, nowadays the young people are very, very computer savvy. हमने तो जिंदगी में काम कंप्यूटर पे किया है, शुरुआत भी की है, पर अब सच पूछो तो today I am learning from my grandson, 7-8 years, दादू इसको ऐसा करते हैं. So the generation has changed, you see. So you must be laughing. This gentleman, I think I must have, by God grace, about 500 conferences, about 32 countries all over the world. I have given the presentation. It's not the first time giving, but still, I have to go to my grandson and ask how to do this. So that's why that is the quality of young brain, you see. Your grasping power, your application to apply the knowledge is much more than the senior. Now we are in the stage of mentor only, you see. You are the person who will be tomorrow what we could not. Okay, well, this is the key next. Now I'm telling how to become leader, how to become entrepreneur. It's not that easy to become. And I must tell you one thing, in absence of Dr. Chauhan, when I was coming here, thanks to Swanee Professor, they were nice to send me vehicle and escort so that I don't run away in between, you see. And that's very good. I enjoyed the company of very young people, you see. One name I know, Prashant, who was sitting with me. I love my students. And you blame me, as I became young in my life, I used to started calling the student as my children, you see. So don't worry, don't go by gray hair. I am the youngest among all of you. Okay. Anyhow, so now the first thing you see, if you go to the Vedas, I am writing a book. Very soon it will be published. The science and technology in the Vedic era. Vedas are not what you think or what you have been interpreted. These are just textbook of science and technology. This is the text. These are the texts of the life. There is nothing which is not mentioned in the Vedas how to do. How to do and what is all this? बहुत अच्छा किसी ने कहा था, डॉक्टर सुधार त्रिवेदी का मैं वीडियो देख रहा था, बहुत अच्छा कहा था उन्होंने. Very nice. You see, Dr. Sudhar Trivedi, don't go with the party and everything. You know what is? He's a doctorate in mechanical engineering. He's an IITian. कोई छोटी मोटी हस्ती नहीं है. And the knowledge of Vedas, I never met him. I only heard on, I only saw on YouTube. Once, just in one of the conference, he was there. So he came and he's a very humble person, very honest. But I didn't have much interaction with him. Time come hota hai inke paas. Anyhow, so he said very nicely, bhai ye batao, नासा तो लाया था 1953 में या 51 में। इससे पहले जो था ये चंद्रग्रहण और सूर्यग्रहण कौन बताते थे? हमारा पंचांग बताता था, हमारे पंडित जी बताते थे। आज हम नासा का देख, मैं नासा के खिलाफ नहीं हूँ, मैंने उसका नमक खाया हुआ है पर मैं आपसे ये कह रहा हूँ कि ऐसी बात नहीं है। हमारे वेदास में वो सब टेक्नोलॉजीज थी, इवन आपके स्पेस क्राफ्ट की, आपकी से they all the drone technology always there, your missiles technology, everything was there. But question is, how do you read it? How do you implement it? How do you apply it? A scientist invented a needle. You can use for sewing the clothes. You can also use for pricking somebody, you see. Anyhow, so well, gentlemen and ladies, we believe in our richest culture of the world, that is Indian heritage, and the first Veda of Rig Veda. It tells you how to become a human being, which includes innovators, which includes leaders, which includes your entrepreneur. Only the person having firm conviction of iron valuation can attain strength and energy at no space does he ever hesitate. Means you have to do the karma. You keep on doing karma anytime, whatever way, he will never hesitate to do karma of any kind. Any kind when I mean, काम कुछ होता नहीं होता. I remember when I was in US, I was after my doctorate in chemical technology. I had a passion for research in space. And before going to NASA, I did, after my postdoctorate, I did my master's in space science in Wisconsin, and that's how I was taken in Space Science Engineering Center within the NASA laboratory. So nothing goes until you acquire something, you have the knowledge, you have got the merit. Advanced countries, when I came back from the States after 2 years, somebody asked, yeah, Goswami, what is the difference between US और हमारा हिंदुस्तान? अब तो हिंदुस्तान बहुत अच्छा हो गया. आई एम टॉकिंग 85 की बात कर रहा हूँ, कई लोग आप पैदा ही नहीं होंगे. मैंने कहा देयर इज वन थिंग, दैट कंट्री merit is never compromised, and my country merit ever compromised. That was the stage, you see. So that, in that country, you see, because I have seen that country very closely, being on a student visa at that time when I was doing my master's, you see, I have lived with the American families. I have worked in the cafeterias. I don't hide. So that's what I'm telling. Don't hesitate to do the karma. So I remember, you see, I asked John, all that time, but you take the job of janitor only, janitor they call it, you see, sweeping job. Yes, they call me my first name, they don't call me by the surname. So they called, yes, Virender, you are right. But why do I do? Because I get more dollars in an island rather than doing the work. That's a dignity of labor. You should not hesitate to do any kind of work. You must to do the work not efficiently, not honestly. That should be your agitation. That's what Rigveda meant. And now if I were to do, what interpretation do you take? Okay, the second thing, how to do innovation, how to do the research and invention. I think I should post some time. I started about 2:40, something like that. So I will try to do in the half an hour, if not half an hour, max of 35 minutes or so. Because other speakers are there, and I'm not that handsome that people would like to see my face for a long time. So anyhow, so I will give you the very good dot point. Read every day something, no one else has read. That is innovation. You must to innovate in reading. You must to research everywhere, you see. Think every day something no one else is thinking. अब ने तुमने ये सोचा कि अमेठी से सेक्टर 18 कितना दूर है, तो कौन सी नई बात सोच ली तुमने? Yaar, can I go from Amethi University to 18 sector, and if I go there, can I learn there? If I can't learn there, can I take the west right? That is innovation. That is innovative thinking. Okay? मैं जो किसी ने सोचा आप सोचिए, किसी ने सोचा तो अगर फैक्टर था जाते समय कि ड्रोन में जाऊंगा, नहीं सोचा होगा. कम लोगों ने सोचा होगा, हमारे ऐसे एक दो पागल लोगों ने सोचा होगा. Anyway, so do every day something no one else will be silly enough to do. Okay? all the scientists were called silly in the beginning, you see. They were called dumb. Thomas Edison was asked to leave the school because he was not performing well. And my mother, she did tell him, this is for parents to learn. Most of people who are online, at least they all are parents, I am sure. And if not, I wish to become one to my parents, you see. You know, the mother of Thomas Edison, I do not have to use Thomas Edison, you see. The light which you are seeing, he is the man behind it, and he tried 9,999 times. And then he became successful. And you know what he did? He said, no, it's not a failure of 9,999. I've come to know that there are 9,999 processes by which you cannot make bulb. That's a positive thinking. That's a positive thinking. That is a motivation. That is the thing to work. I will do it. No, मैं छोड़ूंगा नहीं. I will not quit. लगा रहूंगा. कभी तो किनारे में धार आएगी. और अगर वो आप उर्दू के शौकीन हैं, सभी बच्चों है, ऑल आर आई थिंक बालिग है, सो वह बहुत सा शेयर है. ये लाहौर संस का पायन साहब ने लिखा था, उसमें लिखे से उसने कहा था, तो उससे उन्होंने बहुत अच्छा डायलॉग लिखा था. 10वीं क्लास में था, मुझे अभी भी याद है. मुझे शौक रहा शेर व शायरी का. तो उसमें लिखते हैं वो कि हम वो आर्टिस्ट हैं, जो मार्केट के दवाई पर तब तक अड़े रहेंगे जब तक रही हमारी गर्दन पर हाथ रख के अपने अहाते से बाहर न कर दे. What it meant? It didn't meant Masuka. It didn't meant any love story. It meant what he meant, that I will not quit. I will keep on working, trying until I succeed. And that's what Swami Vivekananda said. Keep on going till you achieve your goal. So these are the people you see. More you are closer to them, more you are also closer to the nature, because they all were very big people. Okay, quickly, well, I have promised that by definitely, I won't be crossing 3:30. Don't worry, because at least 40 minutes to chief guest ko milna hi chahiye. Anyway, this is the tenets of the Nujra. I have told you the basic thing, how to become just in the two shlokas, in the two captions. Now a little bit to make it 40 मिनट में तो पास कर दो, कैसे करेंगे? They are excellent people. जो इन्वेंटर होते हैं वो तराशा हुए लोग होते हैं. ऐसे इनोवेटिव इन्वेंटर साइंटिस्ट नहीं बन जाते हैं, उनको तराशा जाता है. जैसे हीरे पत्थर को तराशा जाता है और हीरा बन जाता है, ऐसे उनको भी तराशा जाता है, तब जाकर वो इनोवेटिव इन्वेंटर साइंटिस्ट बनते हैं. तो एडिस की मैं बात कर रहा था. मदर डिड नॉट टेल हर सन that why you have been asked not to go to school. She said that yes, उन्होंने कहा कि he is not feeling well, let him be little more healthy and put on the weight. उस समय उसका weight कम था, and उसके बाद 1 महीने बाद आ जाएगा. After so many years, when mother has gone, Edison became very famous. However, he caught that school book of the school teacher, in which it was written that you are delivered from the classes because you have failed number of times. Tears came in his eyes. He said, had my mother told me this thing at that time, I could have never become the Thomas Edison, but I am going today. So my dear parents, never underestimate your child, never disgrace him. Don't have the competitions. वो उसके आया 90% तो तुम 90 लाएगा. वो ले आया जितना जो लाएगा लाएगा. Why are you worried about this thing? Life doesn't end with 90%. हमारे टाइम पे डॉक्टर 90% मिलते नहीं थे. 60% आ जाए, गुड सेकंड डिवीजन आ जाती थी, बहुत बड़ी चीज हुआ करती थी. Anyway, sorry. So in my view, you have to have positive attitude. I'll give you a very good example of positive attitude. Good character, you should be a leadership, qualities, and never quit, which I told you, but in my view, you have to have 5 things
to become a good person, good teacher, good professor, good innovator, and finally, and to trash our himself. I give that important to entrepreneurs and patients. Remember, entrepreneur gives job to 1,000 people, while job seeker gets job only for himself. Our country requires entrepreneurs, not the job seekers at all. When I used to get engineering college, 50 years I was in NCRs and other things. And then I become vice chancellor. You don't become vice chancellor overnight. You have to step out of steps. You have to do other things. Okay. So now I have got a list. So these are the 5 things which you have to see. And I think you have to watch your watch. Yes, watch your action, watch your health. When I see somebody else said, but health is lost, something is lost. When health is lost, nothing is lost. Factory is lost, everything is lost. So now I'm going to add this correct okay, this is a very nice shloka of your lecture. Your thoughts go to some language, and you know what the important thing. We're talking only language, speaking, to extent, God will speak in the Punjabi extent, any language, English की बात कर रहा हूँ. But Sanskrit is such a language which will be spoken in one accent. So that means a person who is not having a language or not having the check. Something. जो ज्ञान नहीं है, नॉलेज नहीं है, जो सोसाइटी को बातें नहीं है, जो रिलेशन नहीं करते, वो उसी तरह है जैसे घास चरते हुए हिरण घूमता रहता है. So my dear friends are ask, all things are told, and then this influence of all the readers coming because they not finished Kadachare. Means when you are working, then you should not think about good. It does not say that you should model the result. That's the difference. Okay, next. So live your with the Kudar and live just do your duty. And very nicely said, if you salute your duty, you need not to salute anybody. And if you don't do your duty, वो चमचे वाली करना पड़ेगी आपको. कहीं बॉस वो ना कर दे. पर प्रोफेशनल को ड्यूटी नहीं हाथ करने को हाथ से क्या. So like that is, and this is the your very your innovator leader entrepreneurship. One high tech we told you, very service love was a very good movie in English, and you should always be smiling, laughing. If you can make people happy, you have contributed very big thing in the world. This is the happiness. This I remember one of the quote I got it to but not in the world. And now, so in short, you see, Jamshedpur put after and he went, he said at the last moment, everybody has to have a last moment, you see. He is the most enjoyed thing when I went to audience and the people who were not able to go, I had presented the wheelchairs to them. So when you help something, when you donate something, when you give something. So gentlemen and ladies, so you have to have, I mean, God has given you 2 hands, one to give with it and one to, I mean, take with it. Don't forget to give it. Next, after doing this, is pieces of, I don't think copy it's बात से काम होता है या कलम को बड़ा काफी होता है so this is what I defined what I talked to you, and you can do the prediction, expansion, creation. These are the steps, milestones to do the entrepreneurship. This is again the presentation I will be leaving with your professor. If you are interested, These are the milestones of time. We are not finding these milestones. क्योंकि आजकल बच्चों को तो यार गूगल में मिल जाना है क्या सुनना है उनको बेकार का है Okay, but I don't give granted that everything is my own. We have also taken from a lot of people and learned from a lot of people. Okay, these are the type of research I mentioned in the next picture. And these are the practice of research design that is ready to visualize, calculating. Why I'm telling research, what you are doing, like, the projects which the next I'm coming, because they want to speak on the space projects and what is this should be done. But this you have these characteristics. Next month, well, it's this mathematical questions are brought by the simulation, and I think it's mathematics will get satisfied. The questions are answered. Now, I got something out of discipline, and one some restriction I will not atmosphere because you know that however in what is atmosphere is coming line that is so and that you don't have atmosphere. Okay, now let's go by next week's startup opportunities for the that I thought of. They are the system test. It's system production atmosphere, the new formation of cloud and we are talking about the extent temperatures which can have recently done minus I mean 2 degrees Celsius and this is to see on and this is which was that has appreciated. It was quite clean. If you are interested, the second next method. How can you use it? What you का भी आपने सुना होगा जो आया था तो उसकी कितनी आपने करनी थी spice satellites country requires those spice satellites. But not the picture should be like X-ray film. Most of course, meteorological and सारे आपके such as please. And this was maybe Dr. Prasad, I will request you to give me country work on this time. I can I don't go the solution that is giving me. And one thing the country is raising, not that again I am doing. Dr. Prasad has told me when I that's very good. And but I am also trying to develop artificial intelligence. My knowledge of artificial intelligence, because at that time, this thing we were never taught, you see, but I have next, please. जल्दी से ये सारे प्रोजेक्ट्स आपको अब ये मैंने आपको स्किप कर दूंगा क्योंकि अपना कंट्री को किस तरह से इनोवेशन रिसर्च बढ़ानी चाहिए, कितनी हमारी कंट्री के पास देश में है, कितनी अभी कमी है, किसे करना है, ये सारा इसमें भी चलो बेटे इसको जल्दी से करो। इससे पहले कि लखनऊ जो है जाति आपको लखनऊ का हाउ टू कैच अप आदि इसका तरीका भी दिया है कि किस तरह से हमारी कंट्री आगे कर सकती है। नेक्स्ट प्लीज। These all innovative, it may be right or wrong, not experimented, and what projects for you you have to do experimentation because I don't have facility to do experimentation. God has given it right, but that facility is not with the expiry dates to see. So this is all this is all कैसे करना है ये भी आपको दिया है टॉपिक के बारे में के साथ मैंने solution and last but not least, thank you very much and it's the best. God bless you all. So it's only 20 minutes, which I took the ideal time for any.
Thank you very much, sir, for sharing your thoughts and experience with us. So our next distinguished speaker is Mr. Avinash Mamaraju, Vice President, Space Mission, Dhruva Space Private Limited. Mr. Avinash completed his graduation with MS with MBA from the University of Massachusetts. He worked for 18 years in different roles from business analyst, program manager, associate director, head of delivery, pre-sales head, etc. in areas of SAP and Microsoft technologies. Crossover from SAP to space, leveraging transferable skills and learning new ones, he joined Dhruva Space. He is a strong believer that universities have a critical role in the space economy and have potential to be game changers in this ecosystem. His primary objective at Dhruva Space is meaningful and outcome-driven collaboration with the university space mission. So, over to you, sir.
Thank you so much, Dr. Pani. Thank you, Dr. Prasad and Dr. Shivani. Thank you for inviting me for this presentation. And I would like to share my thoughts and views on the innovations which are possible for the space domain. I have a presentation that I would like to present, and I would like to take some questions after the session is done. 1 second, please. Thank you. I hope my screen is refreshed now. Professor Prasad, if may I start the presentation, please? Yeah, please. Okay, thank you, sir. Like I said, sir, thank you for the opportunity that you have given me to present my views on the space economy and what are the current trends and the opportunities. I like to give you a brief about our company for the audience who know about the company and who may not know about the company. So we are a 10-year-old space company. We are based out of Hyderabad. We are also incubated in Graz in Austria. Our core strengths are in the satellite platforms, satellite deployers, ground station, and also we have few other products in our catalog. So we consider ourselves as full stack space engineering solutions company. What it means is we have a presence and our core strengths are in the space, launch, and the ground segments. So in the recent times, last year in November 2022, we launched our first satellite, which is a 0.5U CubeSat from Sriharikota about C55. And that has been hugely successful. Part of the reason because we were able to share the design, we were able to share the progress to all the ham radio operators all over the world within India, and they were able to conform to the design and able to send and receive messages. We also have a presence in the nano satellite, which is what we call as P30. We have few launches, between 6 to 8 launches planned from today until end of 2024 for some of our commercial customers. And as part of the technology transfer from ISRO, we also have the microsat. We named it as P90. Microsat, we have taken the technology transfer on one of their established platforms, which is the IMS-1. It is coming in 70 kgs, 150 kgs, and 300 kgs. So we also have a presence in the satellite deployers. The hardware which will protect the satellite once the satellite is launched, and it is for the first 5 to 7 minutes, the satellite has to be protected. And after it reaches the intended orbit, the deployer will push the satellite out in the established orbit. So these 1U deployers, there are multiple variants. We start with the 1U deployer, 3U, 6U, and 12U. So we have space qualified the 1U, 3U, and 6U recently. In April of 2023, this year, we had qualified, the 3U and 6U. And by next year, this time, we have plans to qualify the 12U deployer as well. We also have a presence in the ground station segment. We are having primarily multiple variants of the receiving stations working on, say, VHF, UHF, S-band, X-band, KU, and KA band. We have a few installations for the academia, for the commercial customers, and also for the government agencies as such. We also have developed a what we call the software platform. We're calling it as Integrated Space Operations and Command Suite. So this is the platform where we track and monitor our satellites. And we also have some operations that can be performed. Currently, majority of these things are used by different software platforms. But we have taken the best of all the different satellite and utilities around it and created this platform over a period of almost like 3.5 years now. Our contribution is also extended to the space situational awareness, where we have come up with solutions to identify the space debris. Currently, it is in, I would say, beta stage, and after appropriate time, we'll be releasing the details to the print media accordingly. So, just to come to the theme of this presentation to talk about why space is important, I was debating in my head whether the topic, this particular header should be why space is important, or rather to say why it is not important. Now, one of the many things that we can do is to identify the economic opportunity from this domain. Now, space has a large, in terms of the economy, it is more than $360 billion. That was the earlier estimates. With the revised estimates, by end of 2024 or 2040, it will be approximately $1 trillion business. So it has got a huge, I would say, market. It has the kind of economy that we are looking at will enable the countries to be more proactive in terms of the investments and being part of that particular ecosystem. because that will result in a lot of revenue into the economy. So for the economic opportunity revival, this is very important. For the survival and the legacy, the way we owe our presence or to owe our success to ISRO in future generations should also have some kind of reference, some kind of benchmark where they can also say that, yes, something was done in 2023, and therefore this is where we are right now. So that is also important why we have to do this, not for us, but also for the future generations as such. In the interest of the national security, there are multiple scenarios where applications of space has been proved useful, whether it's internal needs or with the international scenario, whether it's war related or any other reporting. The data from the space has been utilized because that is most reliable and consistent to the changing scenarios. It also helps in the sovereign expansion, especially when the clarification of the territory is required. That can be, again, the applications has been for both India and other countries as well, because that is where the source of truth, the data from the space is considered as the source of truth, and that will help them to have a clarity once and for all. Not only it will enhance the diplomacy, the recent times, whether it's a recent G20 session or the elsewhere, when companies collaborate, they have a certain scope, but when the nations collaborate, they have some areas they identify. And in each of these collaborations in the last decade, we have seen a lot of collaborations where space has been included as a key area for the partnership. Not every other country can do. And if we have encouraged our partnership with our neighbors and also with the other nations as well, are part of the diplomacy, it has come up with a very reasonable understanding about the scope of work and also what kind of collaboration is expected with respect to this space, whether it is capacity building or whether it's a technology or whether it is the data or the application of the data. That has given a lot of scope in this particular domain, and that will come up with the next question is, are we ready? Are we ready? Do we have enough know-how to continue this? Like we always say, the space is not a destination, it's actually a journey. So whether we are looking at with the current set of projects from the ISRO, the recent Chandrayaan missions and Gaganyaan missions, which are going to come up in the future, are we as a country or are we as a university, are we ready to take up that challenge to provide manpower to ensure that the workforce building or the workforce development as part of the space capacity building is something that we already have it? If we have it, how effective they are? If not, what can be done? Now that requires a roadmap, and that's exactly Dhruva Space is reaching out to selected universities on this particular domain, because we need some answers to the questions. And I can just quote a recent article where it mentioned that Blue Origin, it's an aerospace company in US, along with SpaceX and other companies, have huge, immense shortage of the manpower. And we are not talking about the I would say mainstream manpower. We're talking about specific skills. Now, education and training, the roadmap has to be there, and the roadmap has to ensure that the needs of the industry are met, because some of the projects do require some specific area, some specific skill set as such. So it is important and imperative to mention or to have a roadmap within the universities as well. The technology development, now the tech landscape over last 10 to 15 years have changed immensely. One guy in US launching 40 to 50 satellites on an average of 4 weeks. Well, in some cases, in our cases, we take like 4 weeks to even schedule a follow-up call. So that is, the kind of urgency that we have. There is a lot of changes which has already happened because of a couple of companies or few companies in the Western Hemisphere. So the key important thing is how are we positioned to meet those challenges? Are we ready to have the technology that has to be developed? We're talking about the satellites, we're talking about the launch vehicles, but there are other downstream elements which are already there. Are we having enough know-how to ensure that we continue to remain the leader in this domain? Because the downside of this is that we may end up becoming a follower, and that will be not be that is not something that we'll be really good at. I mean, traditionally, India always aimed to be, be a leader, not a follower. So that brings into the next point is the international leadership, whether it's Artemis Accord or individual bilateral accords between the two nations. It is important to know how we are positioning space as one of the key factor, and that demonstrates the leadership, that demonstrate that we are ready to take up new challenges. We do have the expertise to execute them. So these are some of the things that distinguish us between a country and one country and another country. And also the environmental experiences, is closely connected with with the education training, whether we have a skill where we can manage their future missions. Now, that is very important because we do have some gap that we see. And the question is how soon we can close that gap. All the programs are domain specific, but space is an interdisciplinary program. Now, we have enough skills to ensure that the programs get executed on time and with the level of the expectations, whether it's meet the expectations or not. So those are the environmental experiences that we need to be very cognizant of. And definitely on the terrestrial services, we need to improvise the global communications, not just for the D2H or on the commercial end, but also have I would say, a comprehensive technology framework where we can continue to communicate with our spacecraft, with our space assets within the LEO, GEO, and also interplanetary missions as well. So, so how do we do that? Now, for the students and also for the startups, or aspiring startups, I would recommend them to first look at the value chain. Space by nature, by the name, it is infinite by both literal and figuratively also. We have many things that we can do, but the way we have to consider is what are the elements that are there in the upstream and both downstream. In the upstream, we do have a lot of institutional and mission operations. We can talk about building the satellites, but essentially we can also think about having the subsystems that have to be designed, manufactured within the India as part of the Make in India program. We can also have the propulsion-based technologies. We have to move away from the standard solid and liquid propulsions and be able to handle the hybrid propulsions, and that will help us or enable us to do more with less. We can also think about the structures, current systems, the current satellites are designed for the LEO orbits, but the minute we're talking about interplanetary missions, the design changes, the structure combination changes. So we need to have enough know-how to ensure that for the given mission specific, do we have all the inputs required? And those are the key elements that I have presented here as part of the upstream. And the downstream, on the other hand, is the outcome. Imagine we have a satellite, the satellite has been launched and the data has been dished out to the nearest ground station. Now, what do you with that data? Now, essentially, for the given mission objective, we can have the different applications of the data, the spatial data, and then you can target it by different domains or different, I would say, different areas that can have a specific space application. Maybe traditionally something else might be doing. For example, I can talk about the aeronautics. I can also have the environment where we have multiple Earth observation satellites that can actually come up and they can give a precise data that environment and water and agriculture is one other area. You can use both the technologies which have come up in recent times from the hyperspectral and multispectral imagery and SAR imagery to the resolution that now we have come to the point where we are having 10 centimeters resolution. So it speaks volume about the level at which we can focus to get the data from the ground using the space assets. Civil aviation is one area. Majority of these automatic dependent surveillance systems are radar-based or ground-based systems. But with the induction of the satellites, we can track and monitor all the space assets, all the flights which are inbound in different countries, in different regions. The same application can be found in the ship fleet management, in the edge, where you can have the different, you can track and monitor different fleets of ship and have a surveillance framework around it, and then a security framework around it, so that the application of that can be, I mean, the end users of that particular application can be from different agencies to even the commercial companies as well. So we also have the space tourism, space education, transport, the logistics play a bigger role in that. Urban planning is also one area where you can use the 2D and 3D rendering of the cities, and then you can plan, and you can have multiple applications as such. So my intent is, these are the some of the elements that we have done. There are again sub elements. As of now, this slide talks about the 40 elements in the both upstream and downstream. But if I'm breaking up, there is a further breakdown, and that comes to more than 200 sub elements, where students as well as the aspiring entrepreneurs can look up and then take a call about what they would like to focus in this particular domain. So the new space economy, these are the top trends that have been observed. This is based on the study that was done in May of this year on 2022 and 23, where majority of the focus has been on the miniaturized satellites and advanced space manufacturing. But you can see the dimension, the framework will change, the priorities will change in the coming years, because the hardware standardization is already happened. NASA has got certain standards. European Space Agency is already having certain standards on how to build a satellite and other space objects. We will also get into the point where standardization of the hardware will happen, and when that happens, we will see the priorities getting shifted. And the key element is whether we are, again, we have to question ourselves is whether we are ready to take up the challenges, because this is where the future is going to be. And this is I would say, the breakup of all the trends that I've been talking about. I'm sorry, any questions?
Another, I think, little 2 minutes more.
Just remind me if the sound is not good, or you want me to repeat something, please let me know. I'll be more than happy to do that. So I was saying, these are the trends contributing to the space economy at this point. We're talking about the small satellite modules, and apart from the regular satellites, operating on the LEO and GEO, we are also looking at interplanetary missions as well. But the key element here is, at least for the first few missions, is focusing on the miniaturization of the electronics and the structures, and that's exactly the CubeSat missions in the recent Artemis 1 had hoped to achieve. The future of this particular approach is also going to be in the secure communication, especially in the quantum communications, where we are going to see a lot of improvements in terms of the way the data has been transmitted and received securely, and the applications that is going to have in the future. And we also have the advanced communications, looking at the antennas which can send and receive messages, so both on the S-band and X-band and beyond. And we are going to see a lot of decentralization of the power for the ground station. That way, we can do more for less, not only talking about the traditional ground stations, but also on the optic and also quantum and optical ground stations, and ground stations which can handle the quantum communications. Space traffic management is one area then where we have a lot of interest, and there are startups within India and outside India who are interested to not only identify and catalog the space debris and the space assets, but also come up with the low-cost measures to handle the debris of the space technologies. Among a lot of things, use of artificial intelligence, robotics has been or will be the the approach that a lot of startups will be taking in order to address the space debris. Space activity management, now ISS is going to be decommissioned by end of 2030, and there are already plans for different companies, not just the agencies all over the world, but also different companies who will be able to launch their own space station and also have a network of those space stations. So that will help us to leverage the investments and also ensure that the collaborative framework that we have between the countries can also extend up to in the space as well.
Avinash?
Yes.
Yeah, hi. We request you to kindly wind up in another 2 minutes. We are running short of time.
Yes, absolutely.
Yeah.
So, and then, when it comes to the space missions, we have a lot of interest in number of missions that can be done, especially on the lunar and Martian missions. Space mining is one area where the entrepreneurs can seriously look into that. Apart from the space data, which can actually translate into some kind of actionable intelligence. So these are the typical trends which are contributing here, and who can contribute? There are multiple, I would say, the disciplines, the students from different areas can actually be part of this and contribute. It's not just aerospace, but we are looking at space sciences, life sciences, medicine, and others. And to draw the inspiration, this is on the lighter note. I have taken from the Star Trek movie, where the inspiration is everywhere. You are looking at the individuals, the characters, but what we need to also look at their qualifications. So end of the day, we do have a requirement to be a part of this space journey. Students and entrepreneurs from different domains can be a part of this. That inspiration can be very simple in form of a movie, or it can be it can be articulated in the best possible form. And to conclude, we have a billion-dollar industry. The collaboration between the industry and academia and the government is not optional anymore. That is what majority of the countries have been doing, and we should also be doing. And for the aspiring startups, my recommendation is to identify your core area of expertise, ensure that the awareness in the domain is a must, and you need to adapt to the dynamics of the organizations and the steep learning curves. With this, I conclude the presentation, and more than happy to take any questions at this point of time. Thank you.
Thank you, sir. So am I audible to you? Okay. Thank you very much, sir, for sharing your knowledge with our students. So question answer session will be conducting after all the sessions.
Okay. Sure.
Thank you. So our next speaker is Mr. Vaibhav Sharma. Hello, Mr. Vaibhav. Yes. So Mr. Vaibhav Sharma, CEO of Aerobotics TechSoft and Aerocut India, is also a recipient of prestigious Baljit Sahni Award from ISRO ex-chairperson Radhakrishnan Swamy in 2014. He worked on GPS error analysis with Professor H.B. Havlani in IIT Powai in Aerospace Department. Beside this, he worked in DRDL. In addition to this, he started his venture named as Aerobotics of TechSoft since 2016. In addition, Aerodrome UAV solution. So over to you, Mr. Vaibhav.
Yes, ma'am. PPT is visible to all of.
You can share your PPT or we will share from this side.
Ma'am, actually already I have given to Dr. Shivani.
Okay, okay.
Yeah.
So we are sharing. Come. इसे शेयर करो जो
Okay, fine. Very good afternoon to all of you. I would like to say thanks to Dr. Shivani and Manish Shankar Prasad, sir, who is the director of MIT Institute of Space Science and Technology, who give me very tremendous opportunity to share my views about the startups in the space domain. So if we talk about the startups in the India is one of the top 5 spacefaring countries in the world. With numerous space opportunity, India is renowned for the producing affordable satellites and the launch vehicles. I would like to tell you that we are the cheapest transportation we are providing to all over the world for the space, right? So estimate value of the worldwide space economy is for 40 million US dollar. Despite this having the most advanced space program in the world, the space sector government of India has started so many projects, reform the encouraging the sports, not in the startups, already giving the MSME sector also. As of May of 2021, India had a total of 368 space tech businesses and placing it 5th in the global arena. So if we say that now India going to give a lot of opportunity in the space sector as well as in the defense also. The specification of the space industry in the enabling services, not in only the surveillance, not only the monitoring, but they are giving such as the media and the entertainment, weather forecasting, disaster management, and the agriculture also. The period of the expansion, innovation, and the faster investment in the industry has started with the opening of the space economy to provide participation, not opening the space economy to the private participation also. So if we talk about like the distribution, please next slide. Next slide. Please next slide. Hello.
Yes, sir.
Can you transfer the slide?
Sir, only 8 slides are visible and that's all we are sharing.
No, actually I'm able to see only a single slide. Yeah, that's good. See, we talk about the opportunity in the space sector as the data we have the satellite manufacturing in the US dollar 2.1 in the 2020. But when Indian government, according to the Atmanirbhar, India has spent 3.2 billions and they are planning to go beyond the 4.5 and the 6 point something billions in the upcoming time. And the launch services, we have again the rising of the investment in the 2025 and we will have 104.6 US dollars. Again, satellite services and the ground segment, these are the segment in which Indian government giving lot of opportunity to the startups and they are investing lot of money to enhance their technical area as compared to the China or USA or you can say the Germans also. So if we go through the again launch services, India has merged as the leader in a third party launch services and they generated US dollar 1607.5 millions by launching satellite for the 26 different nations from 2014 to 2019. It means we can say that within 5 years, we have generated more than 1,600 revenue, and firms are and not invested money. Private space firms are coming up staring to make India a hub for small satellite launches. As Dhruva Aerospace already launched 1-cube satellite, 3-cube satellite. So all these come under the that arena in which launch segment is becoming the key area for startups and small and medium enterprises. As they developed a significant amount of orbit management for the low Earth orbit and medium Earth orbit and geosynchronous Earth orbit. So these are the launch services in which so many companies are working, and they are doing very good. And just because of Indian investment, just because of Atmanirbhar Bharat scheme, under all the startups doing very good. So apart from this, satellite manufacturing, also 84% of the satellite produced globally were utilized for the business communication. But all the startups and the ISRO has become catering to this segment. But the growing demand for the small satellite offer huge opportunity to many private organizations. So this is the second point where all the startups were doing very good in the space industry. And if we talk about the ground segment is also the part of the SATCOM, and the network operation centers and the Earth station compromises the satellite communication. So there are again so many companies, they are doing very good in the ground segment. And apart from that, the satellite services in the segment is currently seeing a boom in the activity due to the supreme demand by the customer, by the requirement of the government. They show their high bandwidth, lower latency, and innovation services powered by the low Earth orbit satellites. So if we go through the more revenue stream for the satellite sector, satellite communication has an impact on many sectors like the position, velocity, timing services. So blue sky analytics and the cover space and many more, they are doing very good in satellite services. So upcoming times, the Indian government is going to develop 2025 4.0 billions amount. Next slide, please. Next, please. Yeah, according to this data, we can say that the investment in the space setup in India has a primary aerospace service provider in the space segment is ISRO. And since its interception in the 1969, however, with the changing ecosystem, India has seen a boom with many private players entering in the space sector and the playing key role in the Indian space economy. And this is the major shift won't revolution the sector by the reducing the cost and the turnaround time with the innovation in the advanced technology. As I already spoke in my last few words, now India is became very cheap transportation for the space. In 600 crores rupees, we can send the Chandrayaan from Earth to Moon, right? So a surprising increment in the investment by almost double the amount in the previous financial year. You can see in 2020 and 2021, it's go beyond double amount, right? So the private sector has been primarily engaged in the developing build to print, manufacturing, giving services, and enhancing the technical arena in space sector, right? So we can say that low Earth orbit player are expressing interest in the partnering with the Indian firm to purchase locally made satellite communications, and you can say the confidence in the satellite producer to attract the services at very low price cost. So at the very low price cost, ISRO and the private firm giving very good services. And for these graph, we can say that the revenue is going in a very good manner, and the number of the new space startups is growing by yearly. In the 2009, you can see we have only 7. In the 2020, again 11 go, and after 21 we have 47, and 2022 we have more than hundreds of startups in which they are doing very good. So I would like to illustrate about more government scheme in which all the startups doing very good. So please, next slide. Yeah, please. First of all is the space remote sensing policy of India in 2022 to promote the communication between ground station to the satellite. Space technology in the space remote policy came in 2020, aims to motivate the different stakeholders in the nation to actively participate in the space-based communication, space-based manufacturing, or you can say the semiconductors also. So easy access to data information from space-based sensing will make a very good opportunity for all the startups. So space asset for the remote data discrimination across India territory. So it will increase if Indian government spend a lot of money for space remote sensing policy under, then we can rectify so many problems. First, already I have discussed with you, space asset for the remote sensing data discrimination across not over India and or nearby the countries also. Remote sensing data services of the Indian territory emerging from the space asset. As we know that we have Gagan, we have INSET also. So these are the satellite which is developed by only ISRO. So after doing a lot of work, now Indian government thought, or they want to generate new firm in which they can do a lot of experiment on the satellite communication, satellite constellation, or we can say the GPS also. So space-based remote sensing system for the social application, strategic purpose, and the research and development. So after investing a lot of money, we can say that in the upcoming time, we will have so many startups in which they will do work on the satellite communication, satellite tracking, and that all the problem will solve by only the startups. So again, next space policy which I would like to share with you and tell you that space communication policy. Under space communication policy, the policy aspires to address the nation's expanding needs to the space-based communication and the creation of technologies for the self-sustenance and in the field of the commercial also. So that foreign space agency just come to us and they give us money to launch their satellite, to launch their constellation in the space. So take action to supervise and approve to use of space asset for the communication for Indian territory. And the second is what? To create the run space-based communication system. The commercial Indian industry need a quick, flexible regulatory environment. So all these points come under the space communication policy. The continued effort of the government of India can be the witnessed in the rising trend in the budget allocation from the financial year in the upcoming time, like 2024 to the 2025. So please next. Sorry, 3 point is left. Yeah. So the Indian National Space Promotion and the Authorized Center is a body which is made by the government, in which their duty promoting the enabling and the authorizing and supervising the all space activities. Like if any education institution wants to launch their satellite, then they have to get the permission from the InSpace. And after all the evaluation, ISRO will launch their satellite. So if we say that if we want to launch the satellite, then with the help of ISRO, we can go through with that, right? So in these offering space-based services, share existing space infrastructure and the facility under development of the Department of Space. So next is New Space India Limited. So to provide satellite services for the divergence domestic and international demands, enabling technology spin-off for the benefit of humanity through the industry interaction and the assisting SME in the expanding their high technology manufacturing for the space technology. So all these policy made by Indian government, and the main intention to create these policies what Indian government can carry out new startups, new brush up different types of mind, and can enhance the technical arena in the semiconductor, space tech, drone tech, and the robotics tech. And the last one is artificial intelligence based, right? So please next. So as we know that in the last year, ISRO launched so many successful projects like Chandrayaan 3, Aditya 1, and in the next month, ISRO is going to launch Gaganyaan and project. So all these come from only these policy in which we are doing very good. And the upcoming, if we talk about the future roadmap, we have Shukriyaan and the Lunar Polar Exploration Mission, which will launch after the 2024. So these are the projects in which ISRO is going to launch, like NISAR, Lunar Polar Exploration Mission. Please next slide. Mangalyaan and the Astro satellites and the space docking experiment. So all these experiment or all these project is going to be launched with the help of private organization, and in the upcoming time I am giving the best wishes to the ISRO, in which we will do very good job. So all these my conversation, I would like to wind up my very fantastic words to give me opportunity to explain my views and experience in the space industry or the drone industry. So so over to the Dr. Shivani.
Okay. Thank you, Mr. Vaibhav, for sharing your views and knowledge. Okay, so next distinguished speaker is Mr. Anup Kumar Srivastava from URSC ISRO. Okay, so Mr. Anup Kumar Srivastava joined Spacecraft Mechanism Group URSC in 2007 after completing his bachelor degree in mechanical engineering from MIT Manipal. Currently, he is officiating as head of electromechanical systems section of Spacecraft Mechanism Group at URSC. In functional capacity, he has officiated as project manager and focal points for several projects, including Indian nanosatellites, CarrotSat series of satellites, Chandrayaan, Aditya L1, like etc. He has been involved in the design and realization of several innovation mechanisms, including UHF antenna mechanisms, nanosat mechanism, DGA version 2, high torque gimbal mechanism, umbilical connector protection mechanism, docking mechanism, etc. Mr. Anup has been a part of several national and international level committees for training and knowledge sharing forums, including National Science Day, Yuvika and Unnati programs, where students and executives are trained by ISRO personnel. So over to you, sir.
Thank you so much. Am I audible?
Yes, sir.
Yeah, thank you. Thank you so much. So first of all, thank you for the opportunity. Thank you, Dr. Prasad, for inviting me for this lecture. And I feel humbled by the presence of so many people. And that was a wonderful lecture by Professor Goswami. Thank you so much for enlightening all of us. I would like to take the opportunity of sharing my screen. Yeah. Okay. So, is my presentation visible? Can someone just signal out?
Yes, sir.
Okay. Yeah. So thank you for the opportunity, and let's start the presentation. So I'll also be speaking on the same topic or the same theme, that is exploring opportunities for startups in space, particularly in India. And before we start up, I just wanted to show a small video of our Chandrayaan 3 mission, wherein how did we realize and how did we go about coming down to a successful landing and rolling onto the lunar surface. So I would like to take the opportunity to show this video. So this is a small realization video where how did we integrate the overall spacecraft, how did we put together everything, and how did we prepare for launch. So here we are on the launch pad, and we are going off with the liftoff. So majestic liftoff we had, and the launch vehicle went up, roaring into the sky, make a thumping presence in the international market. And here we can see how the lander was approaching the lunar surface. We did targeting, we reached the lunar surface, and we did a successful landing. And then the rover came out and touched the lunar surface, and we unfurled our national flag on the moon. So this was a feat that we did. And yes, this is an impetus to all of us, to each and every Indian of this country, to be hopeful towards success, to be hopeful towards achieving greater heights and greater goals in future to come. Going ahead with the same theme. Yeah. So let us first understand what are the 4 paradigms and make startups. So primarily we have got space transportation system where we have got launch vehicles. Then we have the space infrastructure where we have satellites, the space station, the rovers, the modules, everything put together. Then we have the space application. The space application corresponds to various services, the Earth's remote sensing services, the navigation services, the communication services, all those things put together, and we can do a lot of things in that, and I'll be discussing about those things in the slides to come. And then we have the ground segment. For all obvious reasons, ground segment is one of the most important activity when we talk of space infrastructure, because when we have to generate data, there has to be something which has to download the data, process the data, and the outcome has to be meaningful. So putting everything together, we do have some very important segments in the overall space industry. And with that only, we'll be able to move forward and create startups in each and every segment. So here we have the very famous launch for Skyroot launch vehicle, where we saw the first presence of private industry launching their own rocket. That was Skyroot from Sriharipota, and we are all proud of this launch. So without a doubt, someone from the Indian industry took the initiative, came forward, made a launch vehicle, and made a thumping presence in this country in the service of providing launch assistance. Yeah, let's move forward from here. Yeah, so to understand how do we presently space ourselves in various segments which we had mentioned in the presentation in the slides before. So we have got satellite manufacturing, we have got launch vehicle manufacturing, we have got commercial applications, and we can clearly see that in the downstream industry, that is satellite services and the ground equipment, corresponds to 92% of the overall global space economy. So yes, we have to understand something very important, that even though launch, the lucrative part is satellite, the lucrative part is launch vehicles, but the money business, the place from where we'll be able to generate economy, we have to be very clear about it, that the present scenario, we are generating somewhere around 92% of the overall space economy from 2 segments, that is satellite industry and the ground equipment. Going forward from here, coming to the value chain, as we have already discussed, and I understand Weber was also mentioning about the same thing. So yeah, upstream technologies are lucrative and downstream technologies are producing the maximum economy into the overall segment. Upstream technology gives you the niche. It gives you enables you to generate your own data. Without a doubt, it does that. But in order to move in a progressive manner, it's always preferable to start bottoms up approach. That is, we start with the downstream and then we go forward. Seeing the slide and seeing the top right corner of the pie chart, we can see that 51% of the overall space market corresponds to navigation, and we all relate to it because all of us are using GPS in our mobile phones. So navigation corresponds to 51% of the overall market. And yes, navigation is also a strategic area from which we are generating a lot of economy. So what I'm trying to put by all these slides is we have to understand which is the segment from where the economy is getting driven, and then gradually make progress to be able to reach to a stage where we are able to have a sustainable startup. Going forward from here, we have already discussed, and if I'm not wrong, Dhruva Space also discussed about this slide. So I'll not spend a lot of time here. The only point that I want to make here is that many people in the current scenario, though talk of constellation of small satellites, they are ignoring one fact, that is the long-term sustainability of the space mission and space traffic management. And the most important niche area that we have to work upon is the orbital debris control. And if in the current scenario, if for the nano satellites or for the small satellites, if we are able to bring forward a technology which can solve this problem, that is either we are able to quickly deorbit, or if we are able to mitigate this overall situation, we have a breakthrough. So long-term sustainability is an area which all of us have to look forward. Other areas I understand Dhruva Aerospace has already discussed, so I'll not spend a lot of time on this slide. So as we see, based on various niche areas, presently we are having 140 plus space startups, and all of you can find your names here. And I'm happy to see quite a few representation from various industries, which we are seeing on the screen right now. So yes, we have to be optimistic about it, and we can go forward as a country together for developing various important technologies for the country and bringing up. Yeah. What the most important thing in the overall startup regime is the money. So we are also seeing that various startups have been able to generate venture capital, and we can see Agnicool, Skyroot, Vesta, Pixel. People have been able to bring up investments, we can see as high as 15 million. Yeah, so we have an opportunity. It's just that how do we progress? How do we approach, and what is it that we have in plate? So if we have something interesting in plate, we do have someone to serve the plate as well. So yeah, so as we see on the screen, let us be again optimistic and let us move forward to have a new technology or an innovation in the given space startup to be able to have a sustainable progress. Now, what is ailing? What are the problems? What is killing the space startups right now? So I discussed with quite a few friends to find out that some people said that earlier we had a restrictive policy, that is non-government enterprises, that is NGEs, were not given enough representation. But the new space policy does talk of it. ISRO will be acting as enabler, and ISRO will be doing hand holding as well. So if you have an idea, you please approach in space, and ISRO will be there to support to the best possible extent. And we have many people approaching us, and we have been doing free consultancy for many people. So new space policy does open the gates, a floodgate rather, for all the space startups. Taxation regime, earlier it was 18%, and presently, as we understand, it is 0% GST for the launch vehicle capabilities. Yeah, we are working. I mean, I'm from ISRO, so I do not know exactly how the tax regime is going on. But yes, discussions are on to reduce the overall taxation on various other startups as well. But 0% is there on the launch vehicle capabilities. And let us be optimistic yet again. I'll be using this word optimism quite a few times. Okay, lack of funding. As we have already seen in the previous slides, that if you have something interesting in plate, multiple venture capital avenues are present. So let us again have hopes. Lack of institutional support. Yes, we did have lack of institutional support earlier. And presently we have with the constitution of InSpace and NSIL, we have a set standard, we have a policy, we have an institution, and we have handholding. So we have a way forward. We know what it can be done, and there are people to support, there are people to handhold, and there are people to take you forward as well. So yes, what was ailing? We have a solution for all those things. Coming to top trends, I'll not dwell much upon it. I wanted to talk of this space debris management, which I've already done. So we need to move forward from here. We keep making satellites. Yes, all of us can keep making satellites. All of us can keep making launch vehicles as well. But the important factor is, if we are able to mitigate the problem of space debris, you will have an upper edge. So think over this. This is important. Again, coming to advanced materials, all of us presently, if I have to understand, the overall mass is directly restricted by the advanced absence of materials. We have a very small segment of pool from which we select material. So we are not able to just break through the doors and make something very innovative. So if you want to come up with something which is lightweight, and if we are able to do some innovation, the niche area currently is materials. If we are able to bring up material, if we are able to do 3D printing, if we are actually able to come up with additive manufacturing, and if we are able to reduce the overall time frame for the realization of the system, we are in the game. So we need to work upon the niche areas. We need to come up with innovation, and that I'll be discussing as we go forward. We can see innovations in the satellite segments as well. Yes, propulsion. Now, for the nano satellites and the small satellites, most of them do not have any propulsion. They are operated and they are controlled based on the wheels and the momentum wheels. Even some people are using long booms for keeping in the momentum balance. But the current understanding is, if you are able to have green propellant, a very small green propellant for nano satellites, IMS bus satellite, green propellant, small propellants, small propellant based engines, yes, you'll be able to make a breakthrough. Because once the nano satellite is injected and it goes out of control, there is no way to control it. Many small satellite missions, nano satellite missions, I'll be sad to mention this. We have guided many people. I'll be sad to mention this. But the fact of the matter is, most of them have failed. And the primary reason was just the two things. Either radiation has killed them or they were uncontrolled. So we have to work upon the material wherein if we are using quartz material, we should be able to do radiation shielding. And if we do not do anything, we should have proper propulsion system so that at least we are able to control them. So yeah, some things have to be worked upon. I'm just trying to figure out and put some key points so that people think over this and we do come up with some new innovative ideas so that we are able to have a sustainable space mission. Going forward, I'll not take much of time. Earth observation. In the Earth observation, the most important factor is that when we are making technologies, we can have directly services, or we can make platforms, or we can build satellites as well. So this is just an overview which I wanted to give and say that some people can make up a startup wherein we generate a product, that overall product, wherein we convert the data and give a meaningful data for people. But this data will be specific to the user. So coming forward from here, we can also have a platform wherein you can yourself generate a data, something like Bhuvan. Okay, so you have data, but use Bhuvan, use Sentinel data. All these things are available open in the open market. So use this data, come up with a platform, have your innovation, and from there we will be able to have a better startup ideas. Okay, some very interesting startup ideas. I will not dwell much upon it. I have talked of space debris, and yes, we are also seeing that NASA is also working with something known as slingshot mission, wherein they'll not be using any launch vehicle or something. They'll slingshot the satellites into the space. Yeah, these are like sometimes these things look like sci-fi, but yeah, there are possible things, and most of the science fictions have turned out to be realities in the coming scenario. Going ahead from here, I would like to give a small strategy. Am I audible? Can someone quickly point out, am I audible? Just thumbs up, I would say.
Yes, sir, you're audible.
Sorry, my video froze, so that's why I thought, am I audible or not? Okay, so this is my last pointing slide, where I would just like to give a small strategy how to progress for making a sustainable space startup. Here we can see that it's better to develop an innovative data product. And innovation is the catalyst for a sustainable space startup, which is the most important factor. It is the innovation only which will keep us afloat. So let us make an innovative data product using the downstream technologies, then generate revenues, identify a niche area in the upstream technologies. Then most important factor, do not get locked up considering the fact that I will only make a technology for space application. If you have the capability, do think of making it dual use. You should have a market apart from ISRO as well. So if we are able to handle that, if we are able to make a system which can be of dual use, it will be preferable. So make a system which can be used for space as well as ground systems or for multiple applications. Then go for identification of capital investment, so that you have an idea with you, you have some economic background, and then approach InSpace. InSpace is an agency which will definitely provide the support. We do provide facilities for testing. ISRO, I understand most of you are aware of that also. ISRO is providing facility either at minimum cost or no cost, as per the InSpace, as per the new space policy. And then we can develop the upstream technologies, and with that, probably in the time to come, we will have a SpaceX like of a startup in our country as well. And yes, many bright faces, many bright minds are available who will make this dream come true for sure. So with this, I would like to in my presentation saying that all of us have to be patient, we have to be consistent, and we should be able to make a big thumping presence in the international space market. Thank you. Thank you so much for the opportunity.
Thank you, Mr. Anoop. It was a very enlightening presentation. Thank you so much. And the floor is open for the questions, but I would request you to kindly send us your questions through mail as we're running short of time. So we'll proceed with the presentation.
Okay, so now I would like to request Professor MS Prasad to initiate our session chair, Professor Dr. Virendra Goswami, sir.
You must have noticed I was sitting very close to Professor Prasad. More and more vibration I could get. I never knew I will get this off.
Thank you, sir. I request Dr. Shivani ma'am to present the memento to Professor MS Prasad, sir. Now I request Dr. Shivani to present vote of thanks.
Very good evening to one and all present here. So it's a matter of an honor and a privilege to get an opportunity to present thanks for this special event. So as I said, I would like to extend my deep regards and sincere thanks to everyone for his constant guidance and his blessings. I would like to extend my sincere thanks to all the distinguished speakers for taking our time from the busy schedule and being a part of this event. Your talks have been very enlightening, sir. Thank you so much for being here. I would also like to extend my thanks to our Vice Chancellor, Dr. and respected administrator, sir, for the flawless support. And last but not the least, big thanks to all the seen and unseen hands for the unplanned support. Thank you so much.
Respected dignitaries on the dais and off the dais, faculty members, and my dear students, with the blessings of Honorable Founder President Sir, Chancellor Sir, and Vice Chancellor Ma'am, and our Director Ma'am, I, Archana Yadav, your host for this evening, extend a very warm welcome to all of you for this session on nuclear technological sector, present state and future perspectives under the 5th International Conference on Entrepreneurship, Innovation and Leadership, scheduled from 14 to 16 September on the theme of Next Generation Tools and Strategies for Business Growth in Industry 5.0. To begin with the program, I request our session in charge, Dr. Apita Datta, to kindly welcome our guests with a Tulsi sapling. We would begin with our session chair, Mr. Ajit Singh from Atomic Energy Regulatory Board.
Madam Meenu Singh, MD Nuvia India Private Limited, New Delhi. Okay, no problem. Dr. K.S. Golda, scientist, Inter-University Accelerator Center, Delhi. Dr. Tina Goel, Scientific Officer, BRIT, and Madam would be joining us online. We welcome you, Madam Tina Goel.
Ma'am, I'm not able to hear you.
I am not audible.
Ma'am, your voice is not coming to me.
I'll just confirm with the IT help.
Am I audible to you, ma'am?
I'm not mute. Yes, ma'am, you are audible. It's not. Ma'am, still you cannot hear us? पुनीत सर, आप मुझे सुन पा रहे हैं?
मैम प्लीज मैम से बोलिए हेडफोन लगाएंगे या स्पीकर चेक करेंगे अपना।
प्लीज
एक बार फोन कीजिए मैम को या मेरे को नंबर दे दीजिए मैम का
नंबर दे दूं?
हाँ मेरा नंबर दे दीजिए।
हेलो मैम, आपकी आवाज नहीं आ रही है वहां से।
हाँ हाँ, ओके ओके। Next, Mr. Ronak Chaudhary, Director and CMO, ICEIL Private Limited. Thank you, ma'am. Now I request our session in charge, Dr. Arpita Datta, to kindly welcome our guests and speakers.
Hello, everyone. I think I'm audible. Good evening, everyone. Honorable Founder President, sir, respected Chancellor, sir, respected Vice Chancellor, Madam of Amity University, Uttar Pradesh, Session Chair, Mr. Ajit Singh from Atomic Energy Regulatory Board, distinguished speakers, Meenu Singh, ma'am, Managing Director, Nuvia India Private Limited, Dr. Tina Goel, ma'am, from Board of Radiation and Isotope Technology, Dr. K.S. Golda, ma'am, scientist from Inter-University Accelerator Center, New Delhi, Mr. Ronak Chaudhary, Managing Director, ICEIL Private Limited, Head of Institution, Advisor, Guest, Faculty Members, and Students. It gives me immense joy to extend a very warm welcome to all of you present here on behalf of Amity Institute of Nuclear Science and Technology to the panel discussion session on the nuclear technology sector, present state and future perspective. I would like to express our gratitude to our esteemed speakers who have accepted our invitation to join for today's panel discussion session. I would like to thank Amity University Authority for their constant support and to provide such a platform to interact with researcher, industry, and academia. We know that nuclear is already an important part of today's clean energy.
Nuclear power provides about 10% of the world electricity, and nuclear energy is the fifth largest source of electricity for India, which contributes about 3% of the total electricity generation in the country. Our goals are to reduce the carbon emission intensity of its economy by 30 to 35% by 2030, as well as increase the clean energy electricity capacity to 40% of the total installed capacity in the same period of time in safe and secure manner. Not only that, today to benefit mankind, radiation technology has useful application in many fields such as healthcare, industry, agriculture, food processing, archaeology, space exploration, law enforcement, and many more besides electricity generation. In today's panel discussion session, we shall be exploring the advancement in nuclear technology for their beneficial utilization and future prospects for the stakeholders. I am grateful to the speaker of the session who have come here to share their knowledge and views in this important topic. I am sure we'll be having a fruitful discussion here and rewarding exchange in this session, and we look forward to learning about many more advancement in nuclear technology. Thank you so much.
Thank you, ma'am. Now, before I hand over the forum to our esteemed panel and session chair, I would like to take the privilege of introducing the panel. Our session chair, Mr. Ajit Singh, has an experience of more than 13 years working as a scientific officer at the Atomic Energy Regulatory Board, which carries out certain regulatory and safety functions for peaceful purposes of radiation sources in the area of industrial, medical, and research applications. He has been responsible for the development of safety policies, issuance of regulatory consents, and ensuring compliance with the regulatory requirements prescribed by AERB. Before that, he was working as a medical physicist and application specialist in ELTCA Medical Systems, where he was commissioning and installing medical linear accelerators in various cancer hospitals. He has also been a research fellow at the Indian Space Research Organization, Ahmedabad, and worked in the field of microwave remote sensing in oceanography at Space Application Center, ISRO, over the satellite data of Cryostat and Oceanstat. He is a member of Indian Nuclear Society, Association of Medical Physicists of India, and is also a member of Indian Society of Non-Destructive Testing, Indian Institute of Public Administration. Our speaker, Ms. Meenu Singh, she is presently Managing Director, heading Nuvia India Private Limited, the Nuclear Engineering Service and Products Organization, which is part of Nuvia Group and DINSI, the world's largest construction and concessions group. She is handling customers at all stages of a nuclear facility's life cycle, from design, construction, operation, maintenance, and decommissioning aspects. She's an experienced leader with broad technical and business background, having expertise in strategic planning and partnership, international business development, and developing new business lines. She has had a past extensive experience where she has spent 2 decades in the progressively larger positions in building and implementing business strategies, primarily in defense and in nuclear industry. Our next speaker for today is Dr. Golda KS. She has been working as a scientist in Inter-University Accelerator Center and is associated with the General Purpose Scattering Chamber and the National Array of Neutron Detectors. And she was one of the key members who was in the commissioning and utilization of the NAND at IUAC. Her research interests include elastic inelastic scattering, transfer reactions, fission dynamics, simulation studies, and applications. She has authored and co-authored more than 70 peer-reviewed journal papers and more than 150 conference proceedings. Our next speaker who has joined us online is Dr. Ms. Tina Goel. Presently, Madam is Officer in Charge and Scientific Officer, Regional Center, Board of Radiation and Isotope Technology at Institute of Nuclear Medicine and Allied Sciences. She's also serving as a licensee and waste disposal authorized officer for Regional Center, BRIT. Her key areas of expertise include radiopharmaceuticals, radio and photochemistry, theoretical computational chemistry, physical chemistry, to name some. She has been an outstanding record. She has served as the scientific officer at various levels of E, F, and G at the present center, BRIT. Before that, she was working as a scientific officer in DRC, Mumbai. She has many academic excellences and recognitions with her. She has been awarded as a CSIR Nehru Postdoctoral Fellowship Award for carrying out postdoctoral thesis research in IGIB Delhi. She's also awarded a Dr. P.K. Bhattacharya Memorial Young Scientist Award. And she's also the first rank holder in the Homi Bhabha Award recipient in OCES 2002. She has about 19 research papers in national and international journals to her credit and many invited lectures. The last but not the least, we are joined by Mr. Ronak Chaudhary, who is Director and Chief Marketing Officer presently at ICEIL, that's Automatic Chemical Elemental Detection Systems, a startup company that leverages cutting-edge prompt gamma neutron activation analysis technology. And they have been working in close cooperation with technical and scientifically renowned public and private institutions to explore opportunity to commercialize this technology. He has been, he's also the managing director at Beyond Green Energy Private Limited, again, a company which is working for the purpose to develop renewable energy power plants and lead the charge in reducing the global carbon footprint. He is also the director of Steelmont DWC LLC, an international trading company actively working around the world with steel trading experience of more than 10 years. And they are dealing with industrial finished and semi-finished steel minerals and superior grade commodities, including coke, coal, CPC, and iron ore, to name some. So with this, I hand over the forum to our session chair. Sir, you may please take over. Thank you.
Hello. Good evening, ladies and gentlemen, esteemed delegates and distinguished guests. I stand before you today at the 5th International Conference on Entrepreneurship, Innovation, and Leadership to discuss the present status and future perspectives of the nuclear technology sectors in the context of our conference theme, Next Gen Tools and Studies for Business Growth in Industry. The nuclear sector has long been a cornerstone of innovation and progress, providing clean and efficient energy, advanced medical treatments, and enhancing our understanding of the universe. As we gather here to explore the frontiers of entrepreneurship, innovation, and leadership, it's crucial to reorganize the pivotal role nuclear technology plays in shaping our future. The present status of nuclear technology sector is marked by a unique combination of challenges and opportunities. On one hand, we have seen an increased focus on renewable energy sources and environmental concerns, leading to some skepticism surrounding nuclear power. However, it is essential to understand that nuclear technology has evolved significantly over the years. Modern nuclear reactors are safer, more efficient, and produce less waste than their predecessors. Furthermore, nuclear technology extends beyond power generation. It plays a critical role in medical diagnostics and treatments, with advancements such as nuclear imaging technologies and cancer therapy. In the industries of food processing, non-destructive technology, oil well loggings, nucleonic gauging systems, these are apart. Additionally, nuclear science is at the heart of cutting-edge research in fields like astrophysics and material science. Looking to the future, nuclear technology sector holds immense promises. It's poised to be a vital component of the clean energy transition, offering a consistent and low carbon energy source. Advanced reactor design, such as small modular reactors and thorium reactors, are being explored to make nuclear power more accessible and safer. These innovations align perfectly with the conference theme of the next generation tools and strategies for business growth. Entrepreneurs, innovators, and leaders in the nuclear technology sector have the opportunity to reshape the industry by embracing emerging technology, enhancing safety measures, and fostering international collaboration. We must continue to invest in research and development while also addressing public concerns and advocating for informed decision making. In conclusion, the nuclear technology sector stands at the crossroads of innovation and sustainable growth. As we deliberate on next generation tools and strategies for business growth in the industry, let's remember that nuclear field has the potential to be a key role player in the transition to a cleaner and more prosperous future. Together, through entrepreneurship, innovation, and visionary leadership, we can unlock the full potential of nuclear technology for the betterment of humanity. Thank you for your attention, and I look forward to the fruitful discussion and collaboration that will undoubtedly emerge from this conference. Thank you. I will request, ma'am. So I will request Minu ma'am to please come on the dais. Please. Ma'am, we have a limited time, so every speaker is having 15 minutes time. So please conclude. Yeah, please.
Thank you so much. Thank you, everyone. A very good evening. And I hope I don't put anyone on sleep because of the timing of the session. Okay, so I know the subject we've talked about is about the future of the nuclear technologies and the developments. But I think any technology we talk about, the development has to start with the sustainable goal. So to just keep, I mean, I'm sure most of you know about it, but still to keep it in perspective, what is sustainable development? Sustainable development that meets the need of the present without compromising the ability of the future generation to meet their own. As a concept, it is holistic, considering equity across countries and generations. It is also balancing of the competing environment, social and economic factors. Until about 30 years back, sustainability from the perspective of, if we talk about only energy sector, it was more simple with the availability of the fuel type and at the rate of the use. But in today's context, I believe it is more, the framework of the sustainable development is more complex, because in particular to the context of climate change and the environmental degradation, the picture is definitely more complex. And the relationship between the energy consumption and the human development is very clear. Like up to 1,000 gigajoule per capita consumption, a level yet to be reached by 80% of the world population. A country can fundamentally enhance the health, education standard, and the general well-being of its population. Now, the key question is that how do we supply this energy from? And at present, still 80% of the primary energy consumption is from burning oil, gas, and coal, unchanged since 1990. However, the unregulated emissions from the combustions of this fuel are causing definitely the climate change, the environmental damage, and the premature death of the people. And the estimation is around 7 million per year. And if we don't change, it's saying it's going to be at a level of 100 million by 2050. Now, any technology which we are talking about is not without the risk to the environment. For example, while low carbon source of energy we talk about do not emit carbon dioxide, but they're responsible for the emissions and waste during the construction, manufacturing, and decommissioning. Still, the proven, scalable, and reliable low carbon source of energy is definitely nuclear power. And we have to see that, you know, how much we can depend on this to reduce the fossil fuels. And by expanding its use, modern and affordable energy, alternative forms of generation. So I think a lot has been talked about the energy when it comes to the nuclear sector. What we are here talking about is what is the future trend on the technology development, which not restricts only to us the energy. And looking at the forum and the audience, this being the students being the main audience here, I think we need to come out of the mindset of the moment we talk about nuclear as energy. What could be the possible other areas? And I think much more developments are happening in these areas. For example, environment. Plastic pollution is one of the most pressing global environment challenges and a direct threat to sustainable development. The Nuclear Technology for Controlling Plastic Pollution initiative, which was launched in 2021, builds on the agency's efforts to deal with plastic pollution through recycling using radiation technology and marine monitoring using isotopic testing techniques. And the application of one of this in the Philippines is under development, involving the use of radiation to reduce graft polymerization for effective compatibilization for natural fibers with recycled plastics. The radiation-induced polymerization enhances the fiber plastic adhesins, which improves the overall thermomechanical properties of this fiber, which can be used in other technologies, other applications. The other area of the developments which we've seen a lot in the nuclear and radiological is the food and agriculture. Antimicrobial substances such as antibiotics, antivirals, antifungals, antiparasitics are used to prevent and treat infections in humans, animals, and plants. While they save our life, their misuse or overuse on the main drivers for the development of drug-resistant pathogens. The World Health Organization has declared that antimicrobial resistance is one of the top 10 global health threats, which currently leads to 700,000 deaths per year and is projected to reach 10 million deaths per year by 2050. Compound-specific stable isotopes analysis and probing technologies are powerful tools for the assessment of antimicrobial substances. They can be used to measure the ratios of naturally occurring stable isotopes, for example, carbon-13 and nitrogen-15 in environmental samples using gas chromatography, isotope ratio mass spectroscopy, and liquid chromatography. Isotope ratio mass spectroscopy. They can inform environmental remediation decision makers on the potential containment sources and the extent of degradation. The next thing about the human health. Each cancer, is made up of different type of cells. For optimal medical care, treatment selection should be based on the identification of the cancer subtypes that can be easily characterized by nuclear medicine, allowing for a personalized treatment approach. Over the past few years, nuclear medicine has undergone impressive growth with the development of PET, especially using fluorine-18, fluorodeoxyglucose, and new approaches in the targeted radionuclide therapy, among others. Modern nuclear medicine plays an essential role in personalized or precision medicine, allowing the selection of specific treatments appropriate to the individual's patients. This directly contributes to the attainment of the United Nations Sustainable Development Goal 3 on good health and well-being. Now, artificial intelligence. What is artificial intelligence when we talk about for nuclear science and applications? AI refers to a collection of technologies that combine numerical data, process algorithms, continuously increase computing power to develop systems that can approach complex problems in ways similar to human logic and reasoning. Now, combining the isotopic science with the AI, we can provide an interpretable framework to extract new information from small isotopic variations, offering great potential in a multitude of fields, including isotope hydrology, ecology, forsenics, and food security. Experts already apply AI-based approaches to quickly analyze huge amount of water-related isotopic data stored in the global networks. In fusion and nuclear science research, machine learning enables optimization of experimental planning and real-time control solutions necessary for sustainable, safe, and efficient facility operation by maximizing the amount and applicability of information extracted. One of the other field where Dr. Ajit Kumar will be very keen is obviously the radioisotopes and the radiation technology, that there are many routes for the producing medical isotopes used for both diagnosis and therapeutic in cancer, chronic diseases, because they save lives. Ensuring a constant supply of key radioisotopes is essential. Medical isotopes such as moly, technetium-99, fluorine-18, gallium, iodine, deuterium are currently produced globally in research reactors and cyclotrons through nuclear reactions caused by bombardment of technical material. 2 new production routes for moly-99 using linear accelerators and nuclear power plants open horizons for strengthening and empowering the global supply chain of the world's most used medical isotopes. Now, global efforts are also underway to produce medical isotopes for innovative and effective therapeutic agents via photodynamic reactions, notably to produce actinium-225 and copper-67. So, I mean, my whole idea of bringing it here was a perspective that what could be the various career environments requirement available for the students, rather than we are only talking about the nuclear energy. See, nuclear energy, when you talk about a nuclear power plant, I think in India, the NPCIL is the owner and the operator of the plant. They have a very specific way of taking the students. You don't need to be a nuclear scientist to be a part of the nuclear power plant. You need to study core engineering, and then you get into their process through their exams and all. But then apart from that, there is a lot more to look at, as a career options in the nuclear. As I said, you talk about environment, you talk about food insecurity, you talk about human health, you talk about AI, you talk about radioisotopes. So I think even the academia needs to think in that line, that how do we incorporate this subjects or curriculum in a way in accordance with this industry, because I mean, for leaving apart the core engineering, this sectors where specific knowledge, combination of isotopes, radiation, along with the AI, along with the medicine, along with the environment is very, very much missing. And I'm sure industry needs a lot of them. So probably that will give you some thought for the future. Okay. Yeah. Thank you so much for listening to me. Thanks.
Thank you so much, Minu ma'am, for providing about the insights of latest trends and the glimpse about the future coming, the objectives of this nuclear technology. So thank you so much, ma'am. Now I will request Dr. Gola ma'am to please.
Good afternoon. I come from a different background. I'm from academic background. I'm not an entrepreneur, innovator, or a leader. So I'll be talking a different base altogether. So I'm Golda. I represent Indore University Accelerator Center, New Delhi. So I will try to develop my talk in such a way that how the basic research is helping the future technology. So, first of all, I will introduce our institute to you. Mainly, my talk is actually focused towards the students here. For Inter-University Accelerator Center, which was formerly known as Nuclear Science Center, is the first inter-university center of UGC. It was established in the year 1984, and we start functional in the year 1991. We have particle accelerators at our center, and the main mission of Inter-University Accelerator Center is to provide within the university system, within the country, the world-class facilities for accelerator-based internationally competitive research in focused areas like nuclear physics, material science, atomic physics, radiation biology, earth and environmental sciences. For, as I mentioned earlier, the first name of our institute was Nuclear Science Center, and the center actually was established to encourage research in nuclear physics within the country using particle accelerators. And along with this, we offer different other programs also for the university students as well as the faculty, and also the faculties from institutes within the country. So we conduct the accelerator user committee twice a year. This is actually to screen the proposals which are coming before us, so that we can conduct research in the mentioned field using our accelerator facilities. And we do offer a 2-semester PhD program. Students registered in any Indian institute or university or college can come and attend these courses offered by us. And we do give a MSc orientation program. First and final year students from any university can come and do a 3-week project at our institute. And we have a 1-month summer program for BSc students. This is for the 2nd and 3rd year BSc students. For this is conducted in the month of June. So one can actually check our website for these programs. And we also have a program for university and college teachers to train them to use a special tool developed at IUSC for learning science and exploring and experimenting. This particular figure shows the user base of IUSC. That means we have representation from almost all parts of the country. So basically, we are actually training the manpower in the field, in different fields, and the main focus is on nuclear science. So why at all we study nuclear physics? If you want to be an entrepreneur or an innovator, you should know the basic physics. So why do we study nuclear physics? One of the main aim is to study the properties of nuclei, both stable and unstable. And it will also help us to explore the unknown territories of nuclear landscape. And main focus nowadays is the production of super heavy elements. So if you look at the nuclear landscape here, so we have till 2020, about 3,312 nucleides have been discovered in the laboratories. So this is one of the major area of research in the field of nuclear physics. But there are many outcomes from the basic research that we'll come to know in a later stage. So what is the main tool that we have for a nuclear physicist? It is an accelerator. Accelerator works as a microscope. So if you want to see an object, you need the visible light is getting scattered from the object, and we see that. If you want to see an object which is smaller in size, which is smaller than the wavelength of visible light, we cannot see it with our naked eyes. So we need some wave which has a shorter wavelength. So that is why we went for microscope. Here we are talking about a different type of a microscope. We use energized ions to see very small particles. Like for example, here you can see that 100 MeV oxygen beam has a de Broglie wavelength of 0.11 fermion. So the size of the nucleus is 10 to the power 14 meter. And the size of proton is 1 fermion. So this is, if you want to study the nucleus, then you need this kind of energy. If you want to go lower in size, like the core, the size is much smaller than that, and for that you need particles of higher energy. So, but remember, the particle accelerators were invented to make use of them for studying nuclear or particle physics. But as of now, if you see in the present scenario, there are about 30,000 particle accelerators that exist in the world, different types, different sizes. Out of those 30,000 accelerators, about 60% of them are used in the industry and 30% are in healthcare. Only 1% is used for basic research, even though basic research was the main motive behind the invention of the same. So at IUSC, what we have for nuclear physics research, we have 2 accelerators mainly. Even though we have we have 7 different types of accelerators in working condition, and another one is coming up. This is for different other usages. For the main accelerator is a pelletron. This is a DC accelerator, so it can give energies of hundreds of few hundred MeV. So if this particular plot, if you see, this is the energy that available with pelleton, and to study the nuclear reactions, basically you need to overcome the Coulomb repulsion between 2 nuclei which are colliding. For to attain that, you need higher energy. So we have a superconducting linear accelerator to increase the energy of the beam that is delivered by pelletron. So these 2 facilities, like from the first accelerator, the beam can be used for different types of measurement or different types of studies in nuclear physics, radiation biology, material science, etc. For the experimental setup used are different, and for we have a dedicated beam hall for that purpose. So that is called beam hall 1, and the beam which is coming through the LINAC is delivered in beam hall 2, where we have different other types of facilities for this basic research. For the superconducting LINAC delivers beam in beam hall 2 only. The beam from pelletron can be used in both beam hall 1 and 2. And what are the types of beam that we can deliver? We can any stable isotope from hydrogen to uranium except inert elements, and the beam energy is less, up to about 10 MeV per nucleon. So what do we study? The nuclear physics aspect of what are the things that we can study with the present facility that is available to see if 2 nuclei are made to collide each other. What are the things that can happen? For this picture actually represent the evolution of a dinuclear system formed in this nuclear collision. So it has different stages, and there can be different types of reactions, like direct reaction, which it can be simple elastic scattering. It can be some transfer or breakup. This nuclei can break, or there can be fusion, and there can also be fission. So all these stages can be studied by using specific instruments or detectors. So that we have to some extent in our laboratory, so that we can study at different stages. And we study the nuclear structure, energy levels, spin parity, and shape. Similarly, we can also study the reaction mechanism, the cross sections, the time of interactions, the excitation cascade, and what are the parameters that influences the reactions. So these are the facilities that we have at IUSC dedicated for nuclear physics research. So I am only giving the name of it. If I will not be able to explain all the facilities, of course, the students are welcome to visit our center and know more about our facilities. So we have in beam hall 1, we have general purpose scattering chamber. It is a big vacuum chamber where we can keep different types of detectors. And we do have 2 types of recoil mass separators. One is heavy ion reaction analyzer in beam hall 1 and hybrid recoil mass analyzer in beam hall 2. And there is a very large array of natural array of neutron detectors. And for the study of nuclear structure, we have gamma detector array in beam hall 1 and Indian natural gamma array in beam hall 2. Besides these major facilities, we have many auxiliary facilities and add-ons. And we do have a very good computation facility where even the theoretical calculations can be carried out. So I'll just describe 1 or 2 facilities so that you can get a flavor of it. This national array of neutron detectors, it is a facility which is especially used for the study of fission dynamics. How the fission happens after 2 nuclei fuse together, that can be studied using this facility. This has 100 organic liquid scintillators. And I have learned from your faculty that you have some liquid scintillators here also. So this is a larger array. We have 100 detectors and these detectors are placed in a geodesic dome structure and they are all facing towards the target. So and this picture shows the vacuum chamber where the target as well as the particle detectors are kept. Particle detectors can be fission detectors or light charge particle like proton alpha detectors. And here there is mainly since we are studying fission dynamics, for mainly the fission fragments emitted in a reaction are detected, and the detectors have the ability to separate out fission fragments from other reaction products. So this shows how the fission products are separated from other reaction products. Similarly, the neutron detectors are sensitive to neutrons and gamma. So it is important that you separate neutrons and gamma events. So this picture shows how they are separated. And as I told you earlier, we have 2 recoil mass analyzers, which actually helps us to study the residue formed in a nuclear reaction. After fusion, the compound nuclei can de-excite and then it can ultimately form a residual nuclei. So that if you want to detect, then this kind of a facility will help us, because it with a combination of electric and magnetic dipole, it can separate different masses. So by using it is actually separating the m by q, mass divided by the charge state of that nucleus, or charge state of the ion which is coming from there. So this is how actually the super heavy elements are detected. Of course, with the energy available at IUSC, we cannot reach that that mass domain, but we can with the energy available with LINAC, we can go very close to that. And in addition to that, it is also important that we should study the reaction dynamics near the super heavy elements also, so that it will help in improving the theoretical understanding. And for such a super heavy element synthesis experiments, what should be the colliding partners, what should be the nature of the target or projectile can also be determined by this input. And we have a very large gamma detector array. This is Indian National Gamma Array. It is a collaborative project, and Jane was one of the PA of that project. This is actually a collaboration between different institutes and universities within the country. And this array has 24 complex suppressed prover detectors. It is germanium, high purity germanium detectors are used for gamma detection. And the details are given here. The individual shields are obtained at 30-degree angle, and the total efficiency, photopic efficiency is 5%. And this particular array, it can be coupled with other auxiliary setup so that more detailed studies can also be studied. Why do we need? Because all the nuclei are not spherical in shape. When we say nucleus, we always think that nucleus is a spherical object, but it is not true. It can have different shapes. It can have oblate, prolate, or even super deformed oblate or prolate. It can even have a pear or banana kind of structure. So these structures can be studied by using this particular array. And what all these basic research leads to, and this leads to the development of many electronic or mechanical structure within the country. This is actually interconnected. The basic research require this kind of development, and the development of these kind of systems within the country actually give input to the industry outside. So, for example, from the development that we have done for the previously mentioned systems at IUSC, so it involves a lot of work in electronics or mechanical engineering, or even software computer related engineering sections. So these as I showed you, this geodesic structure design needs a good understanding of mechanical engineering, structural engineering. Similarly, we have in-house developed data acquisition system that involves the software development and electronics development. So we have also developed a high density power supplies for the detectors. We have also have the electronics which can actually process the signals from different types of detectors, whether it is neutron detectors or gamma detectors or other types of detectors. And we do have different types of detectors also developed in-house, like these are gas detectors which are operating at different pressure, which can be used to detect charged particles. And yesterday's science is today's technology. So understanding of basic science is very much important for the development of technology. They go hand in hand. So if you see the basic research in nuclear physics or nuclear science has actually developed accelerators, detectors, other allied technologies, and even the understanding of nuclear properties gave rise to many applications in our day-to-day life. So nuclear physics as such has given output to different fields of our life. See, it has influenced the art and archaeology by radioactive dating helps in archaeology, and ion beam analysis also is used in art and archaeology. Similarly, in energy sector, nuclear power, pure catalyst, fusion, heavy ion fission, etc. In materials, ion implantation, micro filters, etc. And space applications also, you might have noticed that even for Chandrayaan they use detectors. Detectors actually evolved or developed in accelerator laboratories in the beginning. And for environmental science, and as we discussed earlier, the medical sector is one major sector which uses both detectors and accelerators. So all these things actually happened, or it has started in the late 19th century by the discovery of radioactivity. Then it moved on, and at that time, nobody has actually thought of the possibilities of nuclear physics in our day-to-day life. But after the discovery of nuclear fission, a drastic change has happened. As you have seen, many of you might have seen the recent movie also based on that. So yes, actually within few years of time, it has come to, of course, the first appeared in the form of a destructive weapon, but soon after that, the nuclear reactor also started operational. For the basic research, how it influences the political, social, and economical side of human development, that is very much showcased by the discovery of nuclear fission. In 1939, it was discovered, and it was in fact discovered in 1938. It was published in 1939. Within the same year itself, the theoretical explanation has also come up. So that fast was the work going on in that particular field. So I'll just give glimpses of some applications of nuclear science in our day-to-day life, like this part of it is already been discussed, that in nuclear energy, nearly 450 nuclear reactors are operational around the world, and 50 more are coming up. And India also has 23 operational reactors. And if you see that nuclear energy contributes nearly to 10% of total electricity, but contributes to 30% of low carbon electricity in the world. And it will continue to be having a major role in the production of electricity and to control the temperature rise, if you can use the nuclear power in the future. Similarly, it has application in healthcare. You know that PET scan or any recent developments in the diagnosis or treatment technology used in nuclear or used in healthcare has a background of nuclear science. For radiation isotopes are required for therapeutic use as well as diagnostic use. So they are produced in reactors as well as using reactors. And then the industrial applications are already been discussed in detail, because it has a wide range of applications in different fields, and we actually are not aware of it. The evolution of semiconductor industry could happen only because the invention of particle accelerators. It is the backbone of the particle accelerators are the backbone of semiconductor industry, and we cannot think of a life without electronics. So there are many opportunities. There is a long way ahead, and with this upcoming head-on therapy within the country, like there are 2 operational equipments in the country, and few more are coming up, and then upcoming reactors and new space programs and accelerator-driven systems. So they're all coming up in the future. So the future is yours because you have scope. With this, I conclude. Thank you. And I acknowledge my colleagues at IUSC for these slides and other boards. Thank you.
Thank you, Dr. Golda ma'am, for enlightening us about the research carried out at IUSC and the future upcoming research programs at IUSC. And also thankful about the objective of IUSC and the future prospects which we which our student can they can carry it out.
in future. Thank you so much, ma'am. Now, I will request Dr. Tina Goel, ma'am, from BRAIT for his presentation. Thank you.
Good evening, all of you. Am I audible?
Yes, ma'am, you are audible.
Myself, Dr. Tina Goel from Board of Radiation Isotope Technology, Department of Atomic Energy. So today I'm going to speak about some latest in nuclear science technology milestones, which is happening in the DAE front. Within this short time span, obviously I cannot mark many of the achievements, but I will try to pinpoint few achievements. With these achievements, maybe I can showcase that how this field is growing and how the main focus is being given to advancement of this technology, this nuclear science field technology in future. So with this word, nuclear science, many applications of this field are coming into my mind, which is like radiation, food technology, application of isotopes in agriculture and refinery industries, radiation sterilization of medical products, etc. But today, mainly two sectors of nuclear science technology I will be showcasing, which is nuclear power and healthcare application. So with the start of nuclear power scenario, what is the scenario? This world is driven by energy demand and supply. Owing to large paradigm shift towards zero carbon emission sources and renewable sources of energy, India has plans to grow its nuclear energy sector. Presently, India is generating only 3% of its total energy production, which is 6.7 gigawatt electrical through the nuclear reactors. But it has goals to increase this target up to 9% of the total electricity and increase this 6.7 gigawatt electrical to 22.5 gigawatt electrical by 2032. Nuclear Power Corporation of India Limited, that is NPCL, is responsible for design, construction, commissioning, and operation of thermal nuclear power plants. Presently, NPCL is running 22 nuclear power reactors, providing 6.7 gigawatt electrical capacity of energy. And recently, indigenous 700 megawatt electrical at Kakrapar reactor is running it in its full capacity. In addition to that, there are 8 more reactors which are coming up, totaling to 6 gigawatt electrical, which are under construction at various stages. Apart from that, 10 more PHWRs are also planned to be installed in fleet mode. Even apart from this NPCL, there is a new phase of nuclear industry developments where India is involving public-private partnership. NPCL is also aiming to involve other public sectors and private corporations in future nuclear power expansion, such as NTPC, National Thermal Power Corporation. Recently, 3 joint venture companies, such as major PSUs in energy area, which they are incorporated to make this combined effort to make nuclear reactors, which is Anushakti Vidyut Nigam Limited, NPCL and NTPC joint venture, NPCL Indian Oil Nuclear Energy Corporation Limited, NPCL and IOCL venture, and NPCL Nalco Power Company Limited. So with this public-private partnership, the scope of growth of this sector is increasing tremendously. In healthcare sector, use of radioisotopes in medicine has been grown over many years. This is because of development of new radiopharmaceuticals, availability of more reliable radiation sources and detectors, greater computational ability to model metabolic fate of radiopharmaceuticals in complex biological systems, and better safety measures while handling energetic radiations. During the last 50 years, DAE has pursued an integrated program to acquire expertise in all these areas. Institutes like Tata Memorial Hospital and radiation medicine centers are among the best in the world, which are giving world-class treatment. Most of the radiation sources and radiopharmaceuticals are produced indigenously to ensure cost-effective treatment. Board of Radiation and Isotope Technology, which is BRID, is responsible for production, quality control, and supply of radiopharmaceuticals in India. Medical products of BRID not only earn revenue, but also sustain the practice of nuclear medicine in several government and trust hospitals by supplying radiopharmaceuticals at low cost. In this competitive market, radiopharmaceuticals at an affordable cost are available in India, mainly due to availability of indigenous products from BRID. Research and development are also constantly pursued to identify new radiopharmaceuticals with potential for use in nuclear medicine, as well as novel approach for preparation of such molecules. With the advancement of technology, new PET-CT and SPECT-CT modalities are also going through quantum leaps in technological sophistication. Many advancements such as lutetium-based scintillators, silicon photomultiplier sensors, cadmium zinc telluride-based detectors are used to improvise image quality and better precision of these instruments. Government and commercial healthcare organizations are expanding research and development efforts with increased funding to produce efficient tailored medicine with few adverse effects. Very recently, only 20 medical cyclotrons have been installed in India till now, but very recently, many more medical cyclotrons, maybe approximately 10 more, and 300 more nuclear medicine centers and PET centers will be mushrooming up to cater increased demand of healthcare sector. Recently, BRIT has successfully commissioned fission moly plant for production of high specific activity molybdenum-99 for supply of radioisotope products used in healthcare industry. With this facility, India will be one of the few countries in the world to have the production capability of medical grade high specific activity molybdenum-99 using low enriched uranium target. This will make India self-sufficient in high specific activity molybdenum-99 and will also enable India to export it. Heavy Water Board, a constituent unit of Department of Atomic Energy, have signed an agreement with Sigma Aldrich Chemicals Private Limited, Bangalore, for supply of heavy water for a period of 5 years for production of deuterated compounds and allied value products. Manufacturing of deuterated products will benefit the country with respect to growth of local chemicals and pharmaceutical sectors, thus increasing supply of high value products. These are all just glimpses of few technological developments which have been happening in government with the partnership of the private sector. So the Department of Atomic Energy is showcasing many career opportunities to the budding nuclear scientists, either by directly recruiting the trainees as scientists or technical officers through training school or direct recruitment, or through their academic program like master's and PhD degree. The HBNI, that is Homi Bhabha National Institute, is the academic wing of Department of Atomic Energy. Many prospects are there open in the international science mega projects like CERN and ITER to take this R&D area of nuclear science and technology students. This is all from my side. Thank you so much.
Thank you, Dr. Tina Goel, ma'am, for this nice presentation about the present status of atomic energy program in India and their developments, and about the DA collaboration with other private sectors with triple B mode, and the opportunities in DAE, how the students can get into the DAE with their other curriculums. Thank you so much, ma'am.
Thank you so much.
I will request Mr. Ronak Chaudhary from AECDS about his presentation. Please.
Yeah.
One important one-stop solution to all your government systems. Our company presents its line of next generation analyzers, which are designed to perform material analysis of a wide variety of industries. These have getting uniform information analysis technology provide companies to lower their production costs and efficiency. Each of these benefits are generate maximum values at the same time, but it is not necessary to repair savings. This saves time and effort to allow for the process money. This in fact contributes to lower costs and increasing efficiency. Is a technical key to improving the presence in the world. Development simultaneously and samples working in size from small to medium large. Once the analyzer adopts the material, including neutron source in its neutrons as a natural sample. The elements of the sample absorb these neutrons and will quantum rays, which are captured and measured by a proprietary gamma ray detectors. Each element needs a unique gamma ray. Through this information, we analyze the composition of quantities of elements. ICEIL is introducing next generation analytical operations and extreme operations. The material is a small standard in continuous work on the structure. A team of experts can develop the product of the universe. Our primary class dark analyzer provides environmental analysis of a range of old materials and excellent precision and reliable results in mathematical types. This elemental analyzer can be used in a range of applications such as sorting, including to environments composition. A smart algorithm automatically adapts to changes in the composition of nature and material. Our range of analyzers is designed for a wide range of industries, including oil and cement, steel, mining, minerals, and biofuels. With the help of can activated analyzers, businesses can optimize different processes such as sorting, material management, etc. Our expertise in GNAA technology providing superior customer support. Our teenage drives to teaching system members. ICEIL will build a relationship in which we continue to support our clients with personalized customer service solutions, which include design, distribution, performance management, and consultancy services. We are using this technology to do that to start up of your industry. Our goal is to make media and technology with a vision to embark in infection across the globe. We believe it's a bunch of IPO. ICEIL, environmental analysis simplified.
So, hello. So thank you, first of all, thank you everybody, and thank you Amity University and Alpana ma'am, Arpita ma'am, for inviting me here and presenting in front of you and the students present here. And as far as we have seen speeches of other dignitaries, I have far less experience than the other dignitaries here, but I have my share of experience of a small startup company which I just started 10 months back now. So basically, I am the director of the company. It's called ACEDS, which stands for Automatic Chemical Elemental Detection Systems. And we have a technical team who looks after the technical of this technology. And we have scientists on board, and we have collaborated with institutes and scientists across the globe. This technology from gamma neutron active analysis is very unique technology. In India, nobody is trying to do or manufacture this kind of equipment so far as we have got to know.
there are companies in abroad, overseas, which are making this kind of equipment, which you just saw in the video. But in India, nobody is manufacturing it. So we feel proud to make this equipment in India and to contribute to this technology, nuclear technology, with the help of institutes like Amity and other institutes which contributes in nuclear technology. So basically, as you have seen in the video, that there is a huge gap in the industries of mining and steel, biofuels, and cement industry. There's a huge gap in diagnosing chemical composition of the material. So basically, what happens right now, they do sample testing. So eventually they do, if they are doing a sample test of 10 kgs and getting mined out 1 ton of the mineral, then there will be some discrepancies. So basically, our technology and the bulk analysis, what we do with our PGNNA technology, is very accurate. It's almost 98% accuracy, and also which does bulk analysis. So no other technology is right now giving these kind of services, and we feel in India there is a lot of potential currently. And as we have done marketing within these 10 months, and we've spoke to other companies, clients, we've got to know that there are a few companies in the world, and these machines are being imported right now. So that means that the mining companies require these kind of machines to do quality control and to save cost and to save time. And so basically, there are companies overseas, then why not there is any company in India? So with that thought, we collaborated with scientists overseas who are willing to do this project with us and want to do in Indian territory and then sell it to across the world. So we feel very proud in doing this business, and which is very niche business also. Initially, I am from non-nuclear background, so I did not know anything about nuclear technology. So I had to learn, I had to see, and from business perspective and things I need to know. And I started doing a lot of meetings, and slowly, I got to know this industry is highly regulated, and of course, they should be regulated because the safety aspect is very major. So I went to AERB, I went multiple times AERB, I went to BARC, I came here, I searched on internet, I searched that Amity has this Department of Nuclear Technology, and I searched other institutes, I reached them, I wanted help, I wanted like how should I start. I needed somebody who's from this industry and who's willing to help. So I reached her, and I am very thankful that Amity University helped me and connected me with the people who are into this industry, and even my company feel very proud to connect with this university who has the presence in a lot of countries. It's not only in India. Amity University has his colleges, but overseas also, and its collaboration. So I would like to tell you about little bit about the technology. So basically, it is called prompt gamma neutron active analysis. Our devices determine elemental composition of samples, bulk load material, and slurries using prompt gamma neutron active analysis. Using this method, a neutron source, example californium or electronic neutron generator, generates thermal neutrons and irradiates a material. The irradiated materials emit secondary gamma radiations of different energies and intensifies, which can be detected using gamma detectors. Because the gamma radiation spectrum thus generated is unique for each element in the periodic table, it is possible to determine the elemental composition of material in a fast, accurate, and reliable manner. Having been used for process control in the coal and cement industry for decades, the PGNNA technology has an established track record of providing real-time data on elemental composition to producers. This enables them to optimize their raw material control, quality mix, boost efficiency, and reduce production cost. The most important difference between PGNNA analysis and other method is that neutrons directly with atomic nucleus rather than just the electron shell, as in the case of electromagnetic radiation such as X-rays. So basically neutron radiations are very unique because it is not charged nor negative, it is neutral. So the penetration rate is very high. It can penetrate at a very high level. So this can be used in multiple applications. This is one of the applications right now we are focusing on industrial application. But in our pipeline, we have a lot of vision right now. We also are right now developing a machine which will do baggage scanning for the cargo. So basically right now in airports or any other security place, what happens, they are using X-rays, but X-rays cannot detect properly. For example, if there is cheese, chocolate or any organic matter, X-ray cannot detect what is it exactly. It can just give you the color combination. So it is right now it is very, for security purpose also for the world, it is very important to have this kind of technology which can basically do elemental analysis and can say accurately what is this. Is it a cheese? Is it a powder? For example, you are carrying a whey protein in your bag, but the X-ray cannot detect if there is a whey protein or what kind of powder is that, because it works on electronic density. It can only detect the density of the thing. So, and our technology basically can penetrate, even if somebody is smuggling something and they put it in a concealed vessel or concealed item, even this neutron, because it has such rate of penetration, it can penetrate into that concealed item and then can act on the subject. So that is it is very unique. And I think I have spoken to many of the clients. They acknowledge it. They know there is a gap. And so far, even for the industrial purposes, I've spoken to a lot of clients and they say that, yeah, there is a problem. So they require a help. So basically, as assets company, we are solving problems. So, and even as ma'am showed the presentation, last few slides I saw, there is industrial application. I could see that there are 3-4 points which were clearly stating a cargo scanner for a neutron generator for detecting heavenly bodies. So neutron generator is very special item basically. So yeah, there are things and we are moving forward with that. And we would like if any of the student wants to, because as we are startup and we require help and we need people in our company. So if anybody wants to speak to us and wants to join our startup company, we have a very small team. Although we have a very small team, but we have a strong team because we have a global presence. So we can connect to any country instantly. So that special power, you can say, we have in our company. And I would like to thank the special dignitaries here present here. And I look forward and thank you very much. Yeah.
Thank you, Mr. Ramanji, about providing the glimpses about the new technology that is PGNA. And you are rightly said there is no as such manufacturer is available in India of this such kind of equipment. So I really congratulate to your company that you will come to India and you're thinking about to manufacturing of such kind of equipment. So as a startup, we congratulate you and our best wishes with you. Thank you so much. So with this sense, end of the session, I am asking about so if you have some queries about with the speakers. So please, if you have some queries, please ask. Yeah. So we can take only 1 or 2 questions. So if you have some questions, please. You must be, I think. Yeah, please, ma'am. A neutron technology. Hello, Tina ma'am. There's a one question for you.
Yeah, please let me know.
Adam, you talked about some Neutron technology for future uses.
Yes.
You said that lots of government and public sector units are collaborating on that. Madam, what is the what kind of uses does it have, Neutron technology?
Ma'am, actually, deuteron is a heavy this thing water. Means it is instead of hydrogen, deuterium is replacing hydrogen in water and in many pharmaceutical components. People have found that after replacing deuteron in pharmaceuticals, their shelf life is increasing. So first, their shelf life, pharmaceutical company is finding lot of application in that. If they can increase their shelf life of the pharmaceuticals. Vaccines, they may not require the cold storage if the deuterated vaccines are there.
Okay.
So deuteron solvents are already there in the market for the use of NMR solvents purpose.
Okay, ma'am.
And deuterated products are also used in optical fibers.
Optical fibers.
Yes. So the deuterated products are having many more applications in semiconductors also, and like that.
Okay. Thank you, ma'am.
Thank you, ma'am.
So you mentioned that technique based on gamma analysis. But handling of neutron flux is more responsible than handling of X-ray. So why you are thinking to replace X-ray?
No, I'm not thinking to replace X-ray. Just additionally, because X-ray cannot give you 100% accuracy. You should have additional screening, level 2 screening. For level 2, you can have our machine and then it can solve 100%. It can give you both the ways. Like
the handling of neutron flux is more responsible and less responsible. So how are you going to handle it?
yeah, we have an RF and also it will have a net shielding. As you were doing one day project, I've seen you doing project in the lab. So we will have proper shielding and it will be compliant with the government rules and we will do all kind of testing. We will do all kind of testing, we'll get the certificate and then only we will be able to sell it. So that is the market practice. You have to follow that.
I will add one thing. Once they will manufacture their equipment, they have to come to ARB for their type approval. And ARB is the regulatory body who will who will test the equipment in all its way and will ensure that equipment is safe for the public and their ultimate users. And they will also ensure that whatever the source they are procuring or for their use, it has to be come in a proper manner and it has to be disposed in a proper way. So there should be no consequences to the environment and the public. Yeah, please.
I'm looking for Dr. Golda. Ma'am, how are superconductors used in accelerators?
Actuators that we have, it is niobium based actuator. So as you know that this what is superconductor means it doesn't have any resistance at that temperature. So niobium when at this these are actually operating at liquid helium temperature. So first they will be cooled by liquid nitrogen and then they will be cooled again to reach the liquid helium temperature. Then you apply a RF rate varying electric field, RF field, and then acceleration will happen like you know that we are applying you are actually letting a ion to pass through in this electric field. When it sees that accelerating field, it will get accelerator. So that is how this superconductivity is used in our accelerator.
Any more question? Thank you so much.
Now I will request the organizers to take over the desk. Thank you, ma'am.
So let us thank our panel for the excellent discussions we had. And I would request Dr. Abhita Datta for the closing remarks. Ma'am, please.
Good evening once again. Firstly, I would like to start by thanking you all, the speaker, for the excellent thought-provoking talks, views, and discussion. And I also would like to thank session chair for organizing and animating the session. Today, we have heard from the speakers about the advancement of nuclear and their contribution for various industries. Let me summarize a little bit of topics, whatever is discussed here. So in this panel discussion, we have the speakers, which I can tell you the amalgamation of industry, research, and academia. And in this panel discussion, there are a lot of important parts were discussed. Specifically to the application part, I'll focus here. So it is starting from the healthcare, and also Dr. Tina Goel ma'am discussed there are a lot of new advancement by developing or by producing different radionuclides. That is one of the very important application. So not only that, even radiation technology is having application which was discussed here. That is in the material science, astrophysics, agriculture, food processing, and many more. Not only that, even one of the speaker discussed about sustainable development in terms of energy sector due to nuclear energy, and also the how nuclear energy can play a role for the solution of the global warming issues. So this is really global warming is one of the concern in everyone's mind, and nuclear energy could be one of the solution for this. And also minimum discuss about the nuclear technology for reducing plastic pollution. I think that will be really beneficial for our day-to-day life problem, and also radiation technology for microbial assessment. And another very important, nowadays everywhere we are talking about the artificial intelligence, and it is also having application in nuclear technology. Ma'am also discussed that if we combine nuclear technology along with AI, maybe efficiency of the techniques can be increased many folds, and they have very potential application in different fields, starting from healthcare to industries. Dr. Golda ma'am discussed about the contribution of IUSC for nuclear physics research, and also how it is helping for development of the new technology. Madam rightly said that yesterday's science are today's technology, and we believe on it, and definitely we need a science for development of any of the technology. Mr. Ronak Chaudhary introduced ACEDS Private Limited to us, which is a new startup company for next generation chemical analysis using prompt gamma neutron activation analysis. And this will help in application in coal industry, minerals, not only that, even in future, many more. So I would like to thank everyone for this excellent session and very interacting session. I can tell you that this session is very helpful for us, even specifically to the student, because I think that they could learn many things about the application, and now they may find different future prospect after completing their degree. And lastly, I would like to conclude by saying that nuclear technology is our gateway to a prosperous future. Thank you all.
Thank you, ma'am. I request our session chair and session in charge, madam, to kindly felicitate our speakers. Madam Meenu Singh from MD Nuvia India. Thank you, madam. Dr. K.S. Golda, Inter-University Accelerator Center. We thank and sincerely acknowledge the contribution of Dr. Tina Goel. She has joined us online. Ma'am, thank you so much for joining.
Thank you.
May we have a
It's my pleasure.
Mr. Ronak Chaudhary, AECDS Private Limited. I request our advisor, Professor A.K. Jain, to kindly join Dr. Arpita Datta in felicitating our chair of the session, Mr. Ajit Singh from Atomic Energy Regulatory Board. Thank you so much, sir, for taking us time and joining us. We thank each of our panelists and the session chair for sparing their time and valuable insight. I request Professor Jain again to kindly felicitate our session in charge, Dr. Arpita Datta. Thank you so much, sir. We are moving towards the last part of our discussion. I request Dr. Sudatta Ray to kindly deliver the vote of thanks.
Thank you, ma'am. It's my privilege to propose a vote of thanks to all dignitaries. Honorable Founder, President Sir, Chancellor Sir, respected Vice Chancellor Madam, our most valued invited speakers and participants. I thank our Honorable Founder, President Sir. It is his vision and leadership that has brought revolutionary changes in the education sector, and streams like nuclear science and technology have emerged with vibrant colors. My enormous respect for you, sir. Our gratitude towards Chancellor Sir and Vice Chancellor Madam for her unlimited support and extending time for this activity. On behalf of AINST and entire organizing team, I extend a vote of thanks to all the speakers for gracing the occasion and sharing with us your valuable experiences. I convey my thanks to all participants, for it is you who are adding value to the discussion. We are encouraged by the presence and benefited by the inspiring address by Chair of Session, Mr. Ajit Singh of AERB of Department of Atomic Energy. Thank you, sir. And I extend a deep sense of gratitude towards our head, Professor Dr. Alpana Goyal, and advisor, Professor A.K. Jain. Dr. Goyal has been a dynamic and flexible person in all academic matters. I'm thankful to Dr. Sanjay Singh, Amity Institute of Aerospace Engineering, for his constant support during the whole procedure. And congratulations to each one of the organizing team members who have been fortunate. We have been fortunate to be backed up by a team of motivated and dedicated team members who had put their best effort for making the panel discussion a grand success. Thank you all. I deeply appreciate all your untiring efforts for both individually and cohesively as a team. And thank you all the senior officials of Administration Department, Amity University, for the infrastructure related arrangement. Thank you all for your participation. Thank you, everyone.